And we're live. Happy Wednesday, everybody. Welcome to yet another episode of Mastermind Academy. We are on week 10, I believe. I think we have 2 more weeks. Actually, let me check the calendar right now. We have 2 more weeks. This is, I guess, technically this is stream number 19. I think I put stream number 20. I don't know. I always get the numbers wrong, but I will get that. Maybe I'll get that corrected pretty soon. But welcome to the stream, everybody. How's everyone doing tonight? Hey, Opus. See you in there with the first comment. I hope you're doing pretty good tonight. Ooh, Kill, I see you restarted your ERP system. That I'm glad that went smoothly for you. Usually when I restart big systems like that, I'm usually feel a little weird, feel a little scared for a few hours after that. So I'm glad that went well for you. Good to see you, Shug. Appreciate you being on here tonight. Well, I feel like Shug's I guess Shug's a moderator now, so I think he can control Nightbot a little bit. So no big deal there. But cool, yeah. Tonight should be an exciting night. So we're finally up to Kubernetes. This is like the biggest buzzword that we've covered so far. We're gonna be kind of building off of the things that we learned. We'll go over the high-level concepts of Kubernetes. We'll dive into what it is. We'll dive straight in. We'll be using we're actually going to be using something called Minikube tonight to do things locally. We're not going to do anything inside of AWS or GCP or anything like that tonight, just because I think it's a better way for you to be able to try to do these things yourself and to get your head wrapped around the things that we're doing. So we're going to dive into that shortly. Going to run through our slides like normal. I think Kubernetes has a little more slides than we're used to, but that's because Kubernetes is kind of a big thing. I've condensed this down into what I think is the important things to help you kind of get started with Kubernetes. This is not the comprehensive Kubernetes course, but I do think it'll give you enough to be able to get in, play around, learn how to do what you need to do with it, and kind of build from there. So that should be pretty fun. No, I don't think I have any announcements. Nothing new since Monday. That's a good thing. Oh yes, there's one thing that's not new, but a little piece of information. The last 3 streams actually all got copyright striked. So YouTube found some violation with the copyright. I think I know why that happened, so I actually just re-rendered them before this, so I'll try to upload them tonight and hopefully they won't get copyright striked. I think there's a specific song that plays on this playlist that's actually not that's all of them are supposed to be copyright free to use. But I think there's one song that's not. I was doing a little research, and so I've pulled that piece out. So there's like a minute or 2 that are missing from the video. But I've kind of stitched that back together, and I think we're good to go now. So I'm gonna try to re-upload those tonight. Really, really annoying. Not sure where that happened. I might need to figure out a better solution for background music. I didn't know that YouTube was that finicky. I didn't know it would catch that much of the background music, but I think I know which. I hope I got it. I think I know which one it is. So hopefully that'll be up tonight. It took a little while for that to re-render, but that's the only bit of news that I have. But yeah, how's everyone doing tonight? How's how's everyone's life going? How's everyone's job going? I'm pretty interested in what you guys are learning. Definitely drop it in the chat if you're up to anything cool for sure. But I think it's up to 18. Yeah, I don't know. I need to count the weeks. The only reason I'm not 100% sure is because I was like, for the streams, we've skipped 2 streams so far. And it's like, hey, we're going to 24. We're supposed to be going to 24. Do I include those numbers? Do I not include those numbers? But yeah, I think it's up to around there for sure. Yeah, we'll count it the first time. Let's have a winner. All we do is win no matter what. I like that. Perfect mindset here. Content, but it's so low in the background. Yeah, exactly. I really weird, and I'm assuming that's the reason. But I'm gonna inquire because it is very low in the background. I didn't think they would be able to catch it. But we'll see what happens. I did reach out to YouTube to see what I could do. Their automatic flagging system is really weird, but there are a lot of ways around it. I found a way to be able to I'm probably going to start completely removing the background audio away from these, but I had to modify my OBS and stuff, the way that I'm recording my audio, to be able to record the sound in a completely separate track. I tried to do it with Audacity. Someone had let me know that I could do it with Audacity. Someone had let me know I could do it with Handbrake. I tried both of those, and I could not get it to work properly. So I just need to adjust my OBS settings so this will never be a problem again. I watched a whole video on it. I just didn't want to mess with my stream setup right now. I'll have a little bit more time this weekend to try that out, but we should be able to knock that out. But let's hop into tonight's going to be a lot, so we should probably hop straight into it and start running over the slides so that we can kind of get hands-on with Kubernetes. So actually, man, now we might have thrown there might be a big wrench that gets thrown into this tonight. Now that I'm thinking about it, the tool that I'm planning on using, which is Minikube, is actually needs VirtualBox to run. So I'm not sure this is set up to be able to run VirtualBox inside of VirtualBox, but we'll find out. And if it is a problem, we will adjust accordingly. We'll set it up so that it can, or we'll find another way to run through these. But hopefully, I'm crossing my fingers. I'm hoping it'll work. But I didn't think about that beforehand. I didn't test that at all. But we will see what works. All right, so container orchestration. We learned a little bit about Docker containers. We learned a little bit about Linux containers, but specifically Docker over the past 2 streams. So tonight we're going to be talking about container orchestration. How do we, scale up these containers? How do we manage, when lots and lots of containers are running? How do we manage that networking? How do we manage how they talk to each other? How do we manage how they are discovered? And so this is what container orchestration does. So what is container orchestration? A lot of words here. Again, just as usual, this is pulled straight from Wikipedia, and we're going to read through it, and then we're going to break it down. But container orchestration is the automatic process. So automated process, that's the key word, automatic process, meaning something you don't have to interfere with, of managing or scheduling the work of individual containers for applications based on microservices with multiple clusters. So what does that mean? What is managing and scheduling? So managing obviously is, making sure your containers are the ones that you want are deployed and they're doing what you want them to do, and making sure you have the right versions and things. That's what managing of it is. And scheduling is a little bit of that as well. Scheduling is setting up and setting forth the operation of spinning up containers and making sure that they are up and they're available as well. So we'll be talking about that a little bit more, but you're managing and you're scheduling the work of individual containers for applications based on microservices. So microservices, we talked about that monolith application, everything kind of in one code base, all dependent upon each other. Microservices is split out, to individual pieces of functionality. So, your business logic may be over here to the left and your database over here to the right. And, you're some other small processing unit up here at the top and your website over here to the right. But microservices breaks that up, and it's a bunch of smaller services that all interact with each other, but they're all independent from each other. And that's really what Docker does well. It does microservices very well. It says within multiple clusters. We're going to talk about clusters shortly. The widely deployed container orchestration platforms are based on open source versions like Kubernetes, Docker Swarm, or the commercial versions of Red Hat and OpenShift. That was just a little throw in there for some of the options you have for this. Kubernetes is not the only thing that you can use to orchestrate. And then over here on the right, we have this image of, the symphony orchestra. We have the conductor up here, and he's orchestrating this. He's controlling what's going on. Everyone's kind of following him, and he's making sure the right sounds are coming out at the right time and the right sections are doing the right things. And that's exactly what Kubernetes does for us. So orchestrators. So what options do we have for orchestration? Over here at the top left, this is Docker Swarm. So you probably heard of Docker Swarm. You might see it when you download Docker or you go to Docker's website. This is an orchestrator that Docker has built. They've built this and they package it up, and they actually, I don't know if they still do, but they used to ship it out with a lot of packages of Docker. But it is something you can get that's built from them. That's kind of their native orchestrator. It didn't take on, people didn't take to it very much early on. It was weird in the way that it operated. I also think people didn't really understand why they needed orchestration yet. This is kind of when everything was still being built up, but it didn't have all the features that people needed. It wasn't as reliable as you wanted it to be, so people didn't really take to it. So it didn't become the industry standard. It's become a lot better. People do use it now in production workflows. People actually use it, but it's not the main go-to. I wouldn't say don't learn it. I don't think it's not necessary to learn. Like, I think you need to know Docker. Don't necessarily need to think you need to know Docker Swarm, but it is an option that you have available to you. And again, it is the kind of official Docker orchestrator. And then in the middle, we have what we're going to be talking about tonight. This is the big boy. This is Kubernetes. Yeah, pretty large project. I guess at this point, a fairly mature project. I mean, I guess it's still, all these projects are still fairly young in terms of open source softwares, but it's pretty robust. A lot of people contribute to it. It's got a lot of cool features that you would want to use, especially on the enterprise level. And then some of the other ones we have. So this is Amazon ECS. I only threw this over here because we've been dealing with Amazon Web Services. And so this is a container orchestrator that's built inside of Amazon. And it's simpler than Kubernetes. They do have a Kubernetes option as well. I probably should have put EKS on here as well. But all the big players have theirs. I think there's a slide later about that. But ECS stands for Elastic Container Service. And this allows you to basically, in an infrastructure as code way, kind of describe the state of the things that you want and send those off to ECS, and ECS will spin up and manage those containers for you and make sure they stay up and replace versions as you like and things like that. So it's a pretty cool product, and it has less features than Kubernetes, but the learning curve is a lot lower, and it's easier to kind of hop into, and it may be a good thing for you if you are in the Amazon ecosystem. Then we have Red Hat OpenShift. This is a non-open source orchestrator from Red Hat, so you may want to check that out. A lot of people use that in enterprise environments as well. And then here I have Cloud Foundry's Diego. So there's a company called Cloud Foundry. There's Pivotal Cloud Foundry, and that's kind of a platform as a service. But they have their own orchestrator called Diego. It's probably not something you'll ever come across often, but it is a option in this space as well. And I want to make sure you knew about some of the options in this space. There are other orchestrators for sure. So if you have one that you use a lot, that you love, throw it out in the chat. We can definitely, throw it out there, mention it, talk about it. Maybe we can hit the website and let us know why you like it so much. Well, cool. So we talked about the orchestrators. Hopefully you kind of understand what container orchestration is. I think you'll understand it a little more once we get hand on if you don't quite understand what container orchestration is quite yet, but hopefully you do. But let's talk about Kubernetes. So this is the pronunciation up top because people pronounce it in 37 different ways, just like the diabetes guy or diabetes, or forgot his name. But yeah, Kubernetes, this is how you spell it. Or this is how you phonetically pronounce it. Kubernetes. So yeah, Kubernetes. But it is a Greek word. I think it's actually a poorly translated Greek word, but it's supposed to mean helmsman or pilot. So that's someone I'm kind of piloting a ship, and that's what it's intended to mean. And that's why you can see here their icon, their logo is this wheel from a big ship, but a pilot or a helmsman, so someone who is in control of this big moving vessel. And so you'll be able to see why that's a good name for this as we get a little deeper into it. It's commonly referred to as K8s or K8s. People pronounce it in different ways. Why is it called K8s or K8s? Because if you take a look here, there's a K, and then there are 8 letters in between. So 1, 2, 3, 4, 5, 6, 7, 8, and then there's an S. So it's an easier way to write it, easier way to refer to it, especially when with a word that long, it's commonly referred to as that. So if you see K8S, they're talking about Kubernetes. So you can, you'll know that now. It was originally developed at Google. But now it is maintained by the Cloud Native Computing Foundation. I believe it's the Computing Foundation. But there's a Cloud Native Foundation, Cloud Native Computing Foundation, who now maintains this. It used to be Google. That's kind of where the project started at, but that is who has ownership of it now. And then one of the big things is, a lot of people don't know this, but it works with more than just Docker. So during the container section, we went over the different types of containers. We went over Rocket and LXC containers and things like that. There are other types of containers, and Kubernetes works with more than just Docker. But I would say 95% of the time, when you see job descriptions and when jobs want you to know Kubernetes, they want you to know it for Docker. All right, so next one. This slide right here is pretty important. I think it's pretty cool. Just to show you how big Kubernetes itself has become. Now, I've never seen job postings for Kubernetes Docker engineers, but maybe I've never Googled that. But I Googled this a lot just to see kind of what people were saying about it. And the salaries for just knowing Kubernetes and like being really good at Kubernetes seem to be pretty high across the board, in the mid 100,000s I was finding as the median salary. So that all changes depending on where you are in the country. See down here, PA and Texas are lower than, New York and Cali, but still great salaries. And usually they're going to want you to know more than just Kubernetes, but I just want to see what, when you typed in salaries for this technology, what you would be getting. And this is kind of the median that I came up with. I've seen salaries a lot higher than this, especially tied in with the other DevOps concepts, if you have those things, going for you as well. So it's not unreasonable to see a lot more than this, to be 100% honest. So hopefully that gets you a little bit excited. Hopefully that gets you a little bit motivated to want to learn Kubernetes as we go through some of this stuff tonight. Senior SRE in Seattle are routinely 160 to 180K. Yeah, site reliability engineers for sure can definitely make that kind of money. And it's not even just in Seattle. Like you'll see salaries close to that, all across the country for sure. Well, cool. So now we know how much you might make. We now should know what container orchestration is. We learned a little bit about Docker, so you should have a good feeling about what containers are for the most part, or feel comfortable approaching it and taking the extra steps to learn it better. We know what container orchestration is. We know about the different orchestrators that we might be able to use, and now we know kind of what kind of money you can make, which I think is very, very important and something that people usually skip over. So we talked about all of the different orchestration services that you could use. Kubernetes is by far the biggest, most popular one. And these are, because of this, there are a lot of managed services behind it. So Kubernetes itself is actually, it's quite a handful to set up from scratch. And so you don't really want to do that. You don't want to have to worry about setting up the infrastructure behind Kubernetes. And so a lot of people provide you resources to do this, that do this for you, pay a little bit for it, but you basically don't have to worry about that major piece of it. And so these are things like Amazon EKS. So this is the Elastic Kubernetes service. Azure has one called AKS, which is the Azure Kubernetes service. I threw DigitalOcean in here just because DigitalOcean is generally the most accessible of the cloud platforms, especially when you're just trying to hop into things. You're trying to learn things, but they have their own Kubernetes platform. I actually don't know what it's called. This is just the logo that I found for it. And then on the right here, we have GKE, which is Google Container Engine. I personally think GKE has done the best, just from the, I don't have a substantial amount of production Kubernetes experience, but from what I can see, GKE is the most well thought out managed service for Kubernetes. Probably comes from the fact that they probably have the most experience with it, being that it was born out of Google. But like EKS kind of just, and Azure just kind of, you need to have a service that does this for you to keep people in your platform. So they kind of just threw up these services that they do okay. They'll do what you need them to do, but some of the things, they don't seem to be incredibly well thought out. They work, but they aren't perfect at all, but they are good. It's easier than setting up your own EKS or your own Kubernetes infrastructure yourself. So these are some options for you. So if you're trying to learn Kubernetes and you don't want to have to worry about the backend infrastructure, you can use one of these to be able to get up and running pretty quickly. All right, so first thing I'm gonna take a break there, ask some questions. If you have any questions about anything that we talked about so far, if you're a Kubernetes expert and you have some great tidbits to drop just about the things that we talked about so far, feel free to drop those in the chat too. We'll go over some of those things. Right after this, we'll hop right into the some key Kubernetes concepts that you need to understand to really understand what Kubernetes does. And then after we learn that, I think we'll just go over Minikube a bit, and then we'll get started. We'll get it downloaded, and we'll start running through some things. In a smaller city, you'd like to see salaries like that. Yeah, I agree. So luckily, out on the East Coast, I'm in Baltimore, because we're so close, our close proximity to DC. We can see, it's DC has pretty good salaries. DC, Northern Virginia, that pieces of Maryland have pretty good salaries. New York-esque salaries for sure. So it's kind of nice being here where it's cheap, but starting to see salaries closer to that for sure. For stopping by, I followed you though. Appreciate it, Adron Hall. Really appreciate you stopping by. Always like to see new people. Always like to see the engagement. I'm glad you come by and drop a little bit of knowledge here. Appreciate you. Appreciate the subscribe kill. I really appreciate that. You're 2 months in. You got a streak going. You got to keep the streak alive. Yeah, it is in smaller cities. It is hard to find. The jobs just aren't going to be as plentiful. And the one good thing about that though is that I found that if you can find the job in a smaller city, they're willing to pay a surprising amount, just because it's hard to find talent in those smaller cities. Find people with the skill set to do these things. But yeah, I mean, you could always go for the remote gigs. So many more companies are more and more open to remote gigs as well, because it's just getting so hard to find that talent that you need to open up your pool to everyone in the country, really. Google Container Engine. Yeah, GK is Google Kubernetes Engine, and not Container Engine. And now, if you're saying that Google Container Engine is better, it's not. Let's see. South Virginia. Oh, Trudeau. What part of Virginia are you in? Yeah, I'm not. I grew up right on the down in PG County, right on the VA border, right across the bridge from Alexandria, not far at all from there. I like Virginia, minus the you guys have crazy traffic cops. Your state troopers are wild, and you guys have 70-mile-an-hour speed limits on your highways, but if you go over 80, it's reckless driving. That doesn't make any sense to me. I told you guys in the beginning, I'm into motorsports, which means, I don't always drive, I don't always drive the speed limit. But going over 80, going 11 miles over the speed limit should not be reckless driving, I think. But so I make sure when I'm going through VA not to speed, but I can never move down there because of that reason alone. So it's Amazon ECS for only Docker and Amazon EKS for Kubernetes. Yes. ECS is for Docker only, and EKS runs the Kubernetes engine, and the paradigm for it is the YAML for Kubernetes. What's the best way to learn Kubernetes, and how long would it take to get the high salary in Baltimore area? So that's an interesting question. To learn Kubernetes, now it depends on how much you know about containers and container technologies, and orchestration technologies. I was able to pick up most of the basics in Kubernetes in about 2 hours, 2 to 3 hours, to really kind of dig in and be able to feel confident that I could get stuff done and deploy stuff, and had a solid understanding of what I needed to do and what was going on. It takes a lot longer to get really proficient at it. There are a lot of pieces to Kubernetes. Like, you can learn the high level stuff, but and kind of how to get started, but it goes pretty deep, and there's so many different pieces. It takes a while to really understand all of those things, and that's why people say Kubernetes has a high learning curve. So yeah, there's a lot of pieces to it. It could take you it could take you years to master, to be honest. But I think if you put in some consistent work on it, I think you can get really proficient in Kubernetes in 2 or 3 months. If you're putting, if that's your main focus and you're putting some good time in it, I think 2 or 3 months is a very reasonable amount of time to get really good at Kubernetes, for sure. But for high salaries, how long it would take, if you're starting from scratch, if like you're just diving into some type of technical engineering, to get to, I don't know what you consider high salary, but I mean, generally, I think your salary can be high once you get that entry level job. If you're in that entry level job for a year, I think you can go make what I think people consider to be a high salary. I think it's all about that first job, just getting your foot in the door, and during that time, really skilling up and making sure you're picking up new skills, and then I think you can move on, and I think you can make really good money after that first job, after you've proven yourself just a little bit. Okay, all right, cool. Watch the video because one says, yeah, it's crazy. Yeah, the key is it's not just to learn Kubernetes, but how to operationalize it, monitor it. 100%. There are a lot of big pieces to Kubernetes. 2 years of experience with that, and you'll get mid hundreds. Absolutely, that's very true. If you just spend the time, you take the time. If you get 2 years of Kubernetes experience, real Kubernetes experience, you're for sure in the mid hundreds for sure. All right, so let's go over some of these key concepts. So the first thing we're going to talk about are pods. So there's a lot of keywords, I guess, in Kubernetes, but pods is kind of the base unit of measurement here in Kubernetes. So we know the difference between an image, a container image, and a container itself. So what is a pod? A pod is it consists of one or more containers, so it can be more than one. So one or more containers that are guaranteed to be co-located on the same host machine and can share resources. Let's break that down because we did not talk about, we didn't really break down the cluster yet, and what a Kubernetes cluster is and kind of what this orchestration tool does. But imagine, I wish I had a whiteboard. I do have a whiteboard over here, but I wish I had something I could easily draw on right now. But actually, I do. I'll go to draw.io really quick because I want to draw this out really quickly. Sure, Google Drive, authorize. Wow. I love that we have so many tools available to us at the drop of a dime. Create new diagram, blank, create. If anyone doesn't know, draw.io is, it was purchased by Google. They didn't used to own it, but it allows you to make cool diagrams and stuff. But I can take this, I can make a couple squares. And so imagine that these are, so over here, I'll see if I can label in a second. These are all servers. All these squares are just simply servers. And make this a little bit larger if I can. And how do I want to see if I can do some text, but this is a okay, so master. This is a Kubernetes master over here. This is the server that's running your Kubernetes code. And it's doing pretty good. He said, dark theme, please. I don't know. Background color. I don't know if there is a dark theme. I should have done that because that's probably gonna mess something up. Is there a dark hue? I don't know where it is. I don't know where the dark theme is, but we'll run through this really quick. This is a master node. And then this is your cluster here. So this whole thing is a cluster, but these are your nodes. And so Kubernetes, the master manages these nodes over here. There's a lot of different pieces of software that run on the master and the nodes as well. But basically, the containers that you're going to deploy are going to run on these nodes here. And so because you have this cluster here, essentially what you're going to say is you're going to write a little thing. You're going to write a little YAML file here. And it's going to say, I want 4 Nginx's. Now that's a dumb way to say it, but imagine you want 4 Nginx services. And what Kubernetes can do, a pod won't do that, but what Kubernetes can do, has the ability to do, what orchestrators have the ability to do is say, hey, this master says, hey, I know you need 4 Nginx containers running or pods or whatever. I don't want to get into that right now. Just 4 Nginxes. Like, I don't want to throw in all the words. Yeah, 4 Nginxes. Actually, so extra theme, dark. All right. I'll refresh. I saw that. I'll make that easier. Hopefully it comes right back. All right. There we go. Dark theme. Cool. So you have 4 Nginxes. The master will say, hey, I just need 4. I want to make sure 4 Nginxes are running. And I have 3 nodes here that I can deploy them on. I could put 1 Nginx. This is a single Nginx. I could put 1 here. I could put all 4 right here. That is what the master could do. It could put all 4 Nginx containers right here. Or, all these nodes could be running tons of other applications, have different CPU loads, etc. And what it could do is say, hey, you just need 4 running, so I can put 1 here because there's space, and I can put 1 here. But you're allowed to spread them out across nodes. And so this, again, don't think about pods or anything right now. I'm just letting you know kind of some of the functionality that an orchestrator can do. It doesn't always have to deploy all these in one place. It can move them around to however many nodes are in your cluster. And it can move them around accordingly. We can put 2 here and have none up there, whatever works. However it decides things will work well, it can go ahead and do that. Wherever it finds space, it can go ahead and do that. And Kubernetes does a good job of networking and making sure everything is in the right place at the right time. So that's what we're talking about when we're talking about a cluster. And now when we talk about, what slide were we on? We were on here. They're guaranteed to be co-located on the same host machine and can share resources. So co-located on the same host machine, that means all the containers that are in a pod. So when you deploy a pod, actually let's say 4 pods. 4 pods. And again, a pod can be running multiple types of containers. It doesn't just need to be running one, but let's say we have 4 pods. This guarantees that an entire pod, if this is one pod that's running a bunch of containers, it will ensure that all of those containers that are in that pod are on the same machine. So everything that exists in that one pod will be on the same machine, will be co-located on the same machine and kind of be networked together, and they can interact and speak with each other. So that is a pretty important piece here. They're co-located on the same machine and they can share resources between them. So they're a grouped up little piece of thing here. So within the pod, all containers can reference each other on localhost. So during the Linux section, we talked about localhost and there being no place like home. We talked about the IP address 127.0.0.1, and that is your local machine. That's what you can always use on a machine to reference itself. So I like my machine. What IP address does it use to reference itself? It's always localhost, which is an alias to 127.0.0.1. So this is great. That means everything in a pod can talk to each other using the localhost domain name. Which is pretty cool. There are a lot more things that you can know about pods, but these are the simplest things. I think the only things you need to understand right now to get started with them. Now, why do I have the images of the whales off to the right? The reason you're looking at images of whales is because this bootcamp is not only designed to make you a great technical engineer, but to make you a smarter, all-around, well-rounded person. And a pod is actually keeping up with the theme of whales. The mascot for Docker is the whale. A pod is actually a group of whales. So, you can have lots of pods. You can have a lot of groups of whales. It's a real nerdy thing that they've done there with that. But a pod is a group of whales. This is a pod of whales. That's why these are called pods. It's also a little bit easier to remember that these are kind of their own self-contained things because the word pod is like a pea pod or something like that as well. But that's why there's some whales over here. Cool. So that's a pod. Again, that's the main unit you're going to be using. The main unit you're going to be using inside of Kubernetes. On to the next thing. So replica sets. This is where Kubernetes gets really cool. And this is what kind of gives you the ability to really orchestrate and to really take care of things for you, and gives you the ease of use to kind of just define how many things you want, and Kubernetes take care of that for you. But Replica sets are grouping mechanisms that let Kubernetes maintain the number of instances that have been declared for a given pod. So that's why we talk about pods first, so you kind of have an idea of what a pod is. But replica sets allow you to set and maintain the number of instances of that pod. So, you know, a pod may have 3 different containers running in it. It may have Redis and Nginx and I don't know, MySQL or something. And you can run one pod contains all these things, and you can run one pod. But a replica set, you can say, hey, I want 10 of those things. And so it'll spin up and manage 10 different pods for you. And it'll make sure those are up. If a pod should die, if a pod should be killed, it will replace that pod. It'll make sure that there are always as many replica sets as you set running. So it's a grouping mechanism that lets Kubernetes maintain is the key word, but maintain the number of instances that have been declared for a given pod. So just basically, you just set a number, you use these replica sets, you set a number, any number you'd like, and it will maintain that number of pods for you. It'll keep that number of pods up. So pretty simple, for a pretty simple concept. You'll see that in action shortly as well. And then let's move on to the concept of services. So all of these, actually, and probably should have put a slide in here for this, but I thought I'm not sure it would have made any sense. But all these are what you call, like, Kubernetes has these things called objects, and all these are various objects inside of Kubernetes. And they kind of do different things. And I didn't really understand the concept of them until I got hands-on with it, so I was going to bring it up then. But all these are kind of their own, like, Kubernetes object items here. But a service, what is a service? A Kubernetes service is a set of pods. So we know what a pod is. A pod can have 1 or more containers. And now we have a set of them. We have a set of pods that work together. So maybe we have different pods, you know, maybe we have multiple types of pods, but they need to work together. So out of that, we will create a service. But so this is such as a one tier of a multi-tier application. The set of pods that constitute a service are defined by a label selector. That's not important right now. I probably should have pulled that piece, but label selectors, we'll get into those as well. But yes, a service is just a set of pods that work together. You can see here this group of kids on the right, they're working together, and that's all a service is. And you can use these services to expose things to the outside world or out of the system as well. And the last, I think this is the last major thing that we're going to talk about, the last major topic. And again, there are a lot more than this. I know I'm missing out on a lot of different things, but namespaces. So namespaces, a lot of words here, but it basically, so it provides a partitioning of the resources it manages into non-overlapping sets called namespaces. All this means is that in Kubernetes, you can basically specify these namespaces that basically partition off or separate assets in the Kubernetes system or resources in the Kubernetes system. So I can have a namespace called, a lot of people use this to separate out their environment. So if you want to have a development environment, you would take up that development namespace, and that would completely separate everything else that's in the staging namespace, and then completely separate itself from everything that's in the production namespace. So it's a way to be able to separate all of the resources that you're using within Kubernetes. But you can use this in a lot of different ways. And it says here, you can use this for many users spread across different teams, or separating environments like development, test, and production. It's a lot simpler than it sounds, but namespaces allows you to partition off resources away from other ones. But that is the last major item we're going to talk about, major concept that you want to get down. So pods, replica sets, services, and namespaces. I probably should have thrown deployments in here as well, because I think we're going to do a deployment shortly. But we'll talk about deployments as well. You always think some things are more important as you're kind of running through it than when you're creating it. But we'll definitely talk about deployments in a second. But how are we going to do this? How are we going to set this stuff up? I already told you that that Kubernetes is kind of this big thing, and it's very difficult to set up a Kubernetes cluster from scratch. I think you can. There is a way, if you're interested in learning that, Kubernetes the hard way. I believe runs through an entire Kubernetes deployment from scratch, I believe. I'll paste that in the chat. And so you can try that if you want, but you don't really, most people don't really need to do this. I think it is something cool to know, but it's a lot of places I won't say a lot of places, but nowadays a lot of people are using those managed services. So we could use those managed services, but I'm not going to use those managed services now because I actually don't know what the free tiers look like for those. Let me see if AWS EKS free tier. I don't even know if it has a free tier. It probably does because I think it just spins up EC2 instances. To be honest, so we could have gone with that. Maybe we'll do that in another time. But we're going to be using something called Minikube, and Minikube is a way to Minikube it uses virtual either KVM or VirtualBox to be able to spin up clusters on your machine quickly, efficiently, easily. But it's not a multi-node cluster. This is not something you can use for production workflows. This is just to give you one node here that you can use to spin up. It gives you a single node which you can use to spin up make your deployments, make your pods, make your services, and do some testing and really learn how to use Kubernetes. So it's a pretty cool one. So Minikube is a tool that makes it easy to run Kubernetes locally. Minikube runs a single node Kubernetes cluster inside a virtual machine on your laptop for users looking to try out Kubernetes or develop with it day to day. So exactly what I just said. Again, single node. Remember we talked about nodes here. Talking about what a node is, you could have multiple nodes. So in a production instance or a production instance where you wanted things to be highly available, you'd have lots of nodes, so you have some redundancy, you have some failover, all that stuff. But this is just going to be one node. So on your computer, it's going to be a single node just like this. That's all Minikube does for you. It gives you one of these and allows you to basically deploy all your pods and stuff onto here, all your applications onto that. And that's it. So if we're gonna in a second, we're gonna get Minikube installed. And again, actually this is actually a big experiment because I don't even know if this is going to work. But if you do exclamation point Minikube, should give you the link to be able to grab Minikube. And let's get out of, I almost closed the virtual machine on accident. So we'll get out of here. So let's go grab it really quick. All right, so let's install Minikube. Let's get this installed. Minikube is actually pretty easy to install. I think they give you a nice installer with both Mac and Windows. For people using Windows, I mean, if you're already using Docker for Windows, it should be fine. I actually don't know how this works. I don't know how this works with if you're running Docker Toolbox. Not really sure how it works, to be honest, but I do believe you can get it to work, especially because Docker Toolbox runs inside of a VM. But we need to, install a few things. So there is a tool here. You'll see here, it'll tell you to install something called, let's make this larger, this small. Install kubectl. So they pronounce it, a lot of people pronounce it kubectl. Some people pronounce it kubectl. I call it kubectl, but I started trying to call it kubectl because that's what all the great Kubernetes people call it. Really weird to me, but yeah, kubectl it's Kubernetes control. That's all it is. But it is a command line tool that allows you to manage Kubernetes and to run Kubernetes commands. So it's a tool that's essential to Kubernetes. You do have to install that, and you do have to install a hypervisor. So the install will probably do this for you. It tells you to do KVM or VirtualBox. I recommend VirtualBox, but it generally will do it for you once you grab the download. So I'm just going to use a package to download it, and or you can just curl. What do I want to do? I'm going to download via package. Make sure I get everything. So I'm going to download the one for my machine. So I'm running, Debian-based distribution. I'm going to see if there's a .deb here. there is one. There's a .deb right here. I'm gonna download that really quick. All right. So I forgot I'm not using. Wait, can you also hear me? I hit the mute button, and then I can't tell if it's muted or not. Should be unmuted. Let me know if you can hear me before I keep saying a bunch of things, or let me know if I am muted. Okay, cool. All right, so I downloaded it. Yes, we'll install that from the command line, because that is we should practice doing more and more things from the command line. So in here, I could have just clicked on the package that was downloaded, but I can go ahead and I can actually install that package from the command line. So I'm gonna go into my downloads where, whoops, that's not my downloads. That looks a little small. Let me, hyper. Let's make this a bit bigger, just a little bit. That might be too, okay, that's better. All right, so I'm in downloads. What's in the downloads? What are we installing? We're installing Minikube. So I can just do sudo, and on Debian-based distributions that are using apt, or you can use this dpkg-i for install, and then the name of the file, and go ahead and enter your password because we typed in sudo, and it's going to go ahead and it's going to install everything for me. So setting up Minikube, and so we should be good to go. So actually, no, I'm gonna type it in. So I typed in Minikube, and again, if you type in the command and it gives you some options, it gives you basically the man page or the help page that tells you what to do, you probably done the right thing. So it tells us we can do a bunch of stuff here. So what I'm gonna do next is I'm actually gonna look back at the installation guide and make sure that we did things that we need to do. One thing I did skip is I skipped installing kubectl or kubectl. I'm never gonna be comfortable saying kubectl. I hate it with a passion, but no biggie. I'm gonna download it. I'm gonna download the latest one here. It says, just type in this command. This is a curl command, and remember, curl is a command that we can use to make web requests from the command line. So what that's gonna do is it's gonna download from this address right here, and it's gonna download it, and it's gonna put it in bin Linux AMD 64 kubectl. Actually, no, it's not. It's gonna download it right. Oh yeah, it's gonna put it. Yeah, it's gonna put it right there. So once it puts it right there, we probably have to give it permissions. So let's see what else it says. It says we can download a specific version, which we don't want to do. We just want the latest, and then we have to make it executable. Remember the chmod command, change mode or change modify. I don't know what it stands for, but it allows you to change the permissions of a file or a binary or a directory. And we added the +X, which adds the executable permission to it, and so now we can execute kubectl. So now we can do that. I'm actually gonna move. Oh, cool. I was gonna say they're a step ahead of me. I should just read through their instructions. I was gonna say I don't like the location of it. I want to move it into user local bin somewhere in my path, so I can just type it in. And they were a step ahead of me. So let's go ahead and copy and do what they said here. I need to stop being so gung-ho. All right, cool. So now we have kubectl. Kubectl. If I keep saying it, I'll get comfortable with it. And then we can check, make sure our version's good. We can already see that it's running. But kubectl, and we'll get some output for our version here. Cool. Excellent. Pretty easy. I probably could have just used package manager here, but oh well. Got it going good. Kubectl's installed. Minikube is installed. So clean up local state. If you previously installed Minikube, run Minikube start. Even if you haven't, you should do Minikube start. I believe Minikube start will download. I believe it'll download VirtualBox if you don't have it. So now we're going to find out whether or not this is going to work inside this virtual machine right now. So yep, you can see here it's downloading a VM boot image. So hopefully my download speeds are great. So we should be fine. This shouldn't affect the stream at all. It's my upload speeds that are awful. But I think I get like 500 or something megs down. So this shouldn't affect anything. And it looks like it's creating a VirtualBox. Retriable failure. The VirtualBox is installed. Oh, so maybe I do actually maybe I do have to install it myself manually. I didn't think I installed it previously. Okay. Well, let's go ahead and try to install. Oh, VBox manage not found. Make sure VirtualBox is installed. The VBox manage is in the path. Okay, no VirtualBox. Let's go ahead and install VirtualBox really quick. I hope this doesn't turn into a big thing. Install Minikube. For some reason I thought it would install for you, but no biggie. Ubuntu. Here we go. Go ahead and install this through Debian. And let's go ahead and use the command line again to install this. So sudo dpkg-i. Let's go ahead and see when it's done. All right, looks like it just finished downloading. It's called VirtualBox something. So we can use our tab complete to get that. So I got to give it the full path because I'm not currently in the downloads directory. Downloads, VirtualBox, and it's going to go ahead and get VirtualBox installed for us. Would the Fedora VirtualBox work for CentOS? I didn't see it listed. Yeah, CentOS should be, yeah, the 3 CentOS ones are right here. This should be right here. Fedora probably would work. It might act a little weird, but I think it should work. But the CentOS and these 3 right here, these should be good. All right. Okay. What do we get here? Now we got another problem. You know what I'm gonna do? I'm gonna use, this is one of the best things about Pop! OS, is I bet you VirtualBox is right here, and it's right in the, it should give me everything I need right out of the Pop! OS package manager. I don't feel like installing these dependencies, which I could, but we're gonna see if this works. I think it'll be fine. Download really quick. Okay, almost done. I do like these emojis in the terminal. That's pretty fire. I really like that. I need to start including that in more of the scripts and things that I write, more of the tools that I write. I think that'll be fun. Makes it festive. All right, so now I have VirtualBox. It opens up. That looks good. So let's go ahead and let's try to run this Minikube start thing again. Let's clear. And let's go start. Okay, this is the moment of truth here. It looks better. I think we got the retriable error immediately last time. So this is looking pretty good. And so the first time you run this, it's going to take a few minutes because again, it's installing an entire virtual machine. It's getting that all set up and getting everything ready to go for you. So give it a little bit of time, especially if you're on a not so powerful computer. Let it go. It'll be fine. Let it do its thing and should be good to go. I'm assuming that there's ways to modify these base settings, like if you're on a computer that doesn't quite have 2 CPUs or that much memory to give off. I wonder if there's a way to set that up. I don't know. I don't have extensive experience with Minikube, but I'm sure there's a way to change that. And if not, I bet you could just change it inside of VirtualBox once it's created. This is I feel good about this. I'm just gonna open this up to see if so cool. It says it's running, which is nice. So I'm gonna let it keep going. And I did actually enable, so while that's going, we can actually go to my desktop view. And I'll do this. And I actually will look in my, let's pull this over. My desktop view. Oh, this is really little. I forgot my resolution is so much higher on my desktop than it is. I'm running a 1440p screen here, but I think when I made this, I enabled a bunch of things. I know you can't see. Okay, I enabled both these extended like hardware acceleration features, so I think we should be good to go. I think it'll work. I wasn't sure if I did that, but I definitely did. Go back to me. All right, so we got past the creating the VirtualBox VM. So it created the VM for us, and now it's preparing Kubernetes to let you know the version, and it also lets you know which Docker version that it's doing. So by default, it runs Docker by default. So like I told you, there are multiple backends that you can use, multiple container services that you can use, but it uses Docker by default. Gives us a little cool whale logo right here. Pretty dope. I already like the people at Minikube even more. I think the first time I messed with Minikube, I want to say it did not have these emojis, so props to them. Whoever submitted this this pull request is the best. Get you a little bit excited for what you're doing. Yeah, anything? I think if there's anything to go over while we're doing this. Actually, I posted the link to this. Yeah, cool. We'll let it go. Not sure how long it takes though. What updates do I have installed? So to actually avoid this though, next time, very soon, I'm actually gonna get a I'm probably always going to run all the boot camps off of a Linux machine, but I'm probably going to get away from running it off of a VM for various reasons. Again, those key shortcuts that cause some problems, some of the things like this with virtualization, etc. Even though I think this is going to work out pretty fine, because I do have that System 76 Linux laptop, and I do have a capture card. I'm actually going to start. Eventually, I'm gonna set that up to basically running the stream, through my main desktop rig. But I'm actually going to be using the dedicated Linux laptop to be able to do that through, to make sure we don't have any weird virtualization issues. Hey, what's up, girl? Yeah, so we'll probably do that next time. You guys can probably hear my dog. She ran upstairs. She's pretty happy. She probably wants me to take her outside, but she'll be all right. Are we going over Helm charts? So we will not be going over Helm charts tonight, but we will be doing a full Kubernetes, a full Docker and Kubernetes like workshop in between now and the new year. And we will absolutely be going over Helm charts then. We'll not be going over Helm charts tonight, just not quite enough time to do that tonight. But how does running a VirtualBox affect the MTU? If for MTU you're talking about that's mail, right? I actually don't. If MTU is mail, I have no idea. Unless you're talking about a piece in Kubernetes, I'm not sure what you're talking about there. And if there is an issue, I have no idea how it's going to affect it, because I've actually never run. I've never done this before, so I've never used Minikube inside of a virtual box like this, inside of another virtual machine. So we're doing a little bit of a virtual machine inception right now, if people didn't know. So this is running, and again, desktop view. So I'm running this virtual machine right here, and then in here we are basically spinning up another VirtualBox virtual machine, which is the Minikube instance. So we're doing a little bit of inception here. Or if it's a network MTU, yeah, yes. I mean, it's a good question. We're about to find out how it does, because it could be bad. But if it's good, maybe I'll keep doing this in virtual machine, because it is nice to be able to work right off of my desktop. But yeah, we'll find out in a second. I'm using a VM running on ESX host. We'll see how it goes. Yeah, hopefully, I think it'll be fine. And actually, I guess my laptop is much more powerful than this, but like, this is taking longer than it took on my laptop, but cool. I guess we're all done now. So we're all finished here. Let us know everything that it was doing. It pulled some images. So we have some images that we need already downloaded. It launched Kubernetes, and it was waiting for etcd and the scheduler and controller DNS to start. So these are just pieces of Kubernetes. And again, I said there were a lot of different pieces of Kubernetes. These are a lot of very important pieces that they're important, but we're not going to go over them because I think it's confusing for now. But yeah, these are all things that help run Kubernetes. They're very important for Kubernetes operation, and then let you know that it's done and that you can use this kubectl command is now configured to use Minikube. So now this kubectl command is now pointed at Minikube. So the kubectl command, we can do a bunch of stuff. One of the common things you're going to do is this git command to be able to find out about what resources you have. And right now, I probably don't have anything. But these resources, these objects that we were talking about before, I can just run a couple commands really quick, and I can do kubectl git pods. Do I have any pods running? I have no pods running. Do I have any services running? I should have no service. I have a service running. So looks like Kubernetes created a service for me here. So there is a service running. Get a replica controller or a replica set. We shouldn't have a lot of stuff here, but there's a lot of options for this. Deployments, because we are going to go over deployments. Okay. There's nothing really running here. It's just Kubernetes. And again, this is just a virtual machine that is running. So for right now, we don't need to run any other Minikube commands. So what we're going to do actually is we're going to run through, Kubernetes has an application. I saw this like 20 minutes actually before I started. I was going to show you guys some basic, like there's a few Kubernetes demo things that they're basically like hello world apps. Like there's like a node one and a couple other things that connect to each other. But it looks like Kubernetes has some type of demo app on their site. I want to see if we could set that up. Kubernetes demo app. I can't spell demo app. All right. They have something. Yeah, this PHP guestbook. I was looking at this for like, I was literally looking at this for like 30 seconds, and it looked kind of cool because we're gonna set up a bunch of different things, and I learned something cool that I did not know about Kubernetes, and about the kubectl command with create, and we're about to go over that. So I'm gonna send this, and let's just run through this. If this doesn't work out well, we can start to set up some of these hello world apps and stuff in here, but check that out. We're gonna see. I have no idea what this PHP guestbook even is, but we'll see if we can get it running, and hopefully we'll be able to talk through some great things, and talk through what we kind of learned through the slides, and you can see it running here. But one of the main things to know about Kubernetes is just like all the other things that we've been learning so far, especially as we have gotten into the infrastructure as code piece, is that Kubernetes is written the way that you write these Kubernetes manifests. I don't even know what the word is for the files that you use for Kubernetes, but they are YAML files. We've talked about YAML a bunch of times. You've seen YAML. You've seen it as we were writing Docker Compose. You've seen it as we were writing Terraform, a little bit of CloudFormation. I think we did like one CloudFormation template, but you saw it with Terraform. But YAML is kind of the de facto format for DevOpsy tools to be written in nowadays. So once you kind of get the feel of YAML, it's useful across many different things, but YAML is how you write these things. So let's read a little bit about what this is going to do. So the example here, they have deploying PHP guestbook application with Redis. This tutorial shows you how to build and deploy a simple multi-tier web application. So this is what Kubernetes is good at. So it has multiple tiers, and we're deploying an application that's using Kubernetes and Docker. This example consists of the following components. So these are the different components we have. We have a single instance of Redis master to store guestbook entries. So Redis, we can show you what Redis is. Redis is a open source in-memory caching tool, a data structure store used as a database. So it's a caching tool, in-memory caching tool. Pretty popular piece of technology. To run via containers. And so we're going to spin up one master node here for this, one master store for Redis. Then we're going to spin up multiple replicated Redis instances to serve reads. That's interesting. So we're going to have basically this one server that's kind of the main server, the kind of server that kind of oversees everything and is the source of truth. And then we're going to run a bunch of other services, multiple replicated Redis services that basically are copies of the master that we can only read from. We can't write to it. But we can use that to get information from. And then we'll have multiple web front-end instances. So we'll have a three-tier application here. So that actually sounds pretty cool to me. Yeah, so objectives, we're going to start up the Redis master, start up the Redis slaves, start the guestbook front end, expose and view the front end service, and clean it up. So pretty simple. Before you begin, looks like they recommend using Minikube as well. Or you can use these Kubernetes playgrounds. I don't know anything about these, so maybe I'll paste these in if you aren't able to get Minikube installed. But it looks like you can use these to try out Kubernetes yourself. Or without setting it up locally. Someone could try it out. Let me know how you like it. I've never used either one of these, so please don't blame me if these are I don't know, these are spam sites or something, but they should be good to go because they're on the official Kubernetes site. Hopefully they're good to go. Cool. So that's the before you begin, and then now it looks like it hops right into the where we actually begin. So let's stop there. Let everyone kind of get to this page if you want to get to this page, if you want to follow along. Let you take a step back and kind of gather in what we've done so far and kind of pick up what we're about to do. Looks like Kill, you had to enable virtualization. Yeah. 6 core, 16 gigs of RAM. Just for the overkill factor. I agree. I should have probably hyped this up a little bit. I think this is running like, what am I running on this virtual machine? I am running, oh, that went away. I'm running 4 vCPUs and I am running 8 gigs of RAM. I'll give it some more. I got 32 gigs of RAM on here, on this PC, so I should be good to go. But this should be fine, I hope. All right, so we're about to start up this Redis master, and I'm hoping it looks like they're going to give us the files, and so we'll hop on that in a second. But the goal of this, again, is it's important that I don't know what the end state of this is going to be, but we don't care about what you don't care right now. Redis is not the thing that you're trying to wrap your head around. Don't worry about what Redis is. Don't worry about what Redis is doing. I want you to realize that one, a lot of applications have this kind of master slave setup where they have a main service or main server or service running, and they have some replications of it that are running that you can use to get information from but not write to. So that's important. But just to kind of see how we because this is a common paradigm, just watch how we kind of deploy this multi-part application. Again, you don't even know what Redis is. You don't even need to know what this guestbook is doing, but you need to see that there are 3 main pieces to this application that it sounds like we're going to be putting together in Kubernetes and sticking together, and I guess they're going to create something cool. So that's what we're going to go through. Pick up the Kubernetes commands. There's going to be a lot of kubectl commands here, I believe, and pick those things up and kind of see how we're managing Kubernetes, see how we're using services, see how we're using pods, see how we're using deployments. It's to kind of see if you can start to put a picture in your head of how those things kind of fit together. Because again, Kubernetes is kind of a big thing, and if this is your first time hopping into it, it can be pretty confusing. So start to put that picture together in your head as we're running through this stuff. All right, so the guestbook application uses Redis to store its data. It writes the data to a Redis master instance and reads from multiple Redis slave instances. So again, as many times as they say this, this is a great paradigm. If this is, if you're diving into DevOps for the first time and you've never really dealt with, production infrastructure, this is an important paradigm for a lot of applications. A master node or a master instance that basically is the source of truth. This is the main thing that's running, and things can be written to that. So why would you want something like this? Let's say it's a database. And so a database, let's say you have people putting information into your database and your application is getting information out. So maybe you have people signing up at the same time your backend is getting information about those people who did just sign up. So the problem is let's say you have multiple databases because you need to serve a lot of people. You don't want to be writing things, if Jimmy signs up over and he's connected to this database and he signs up and all of his information goes into this database, if if the system is trying to get information about Jimmy's account, you know, after he logs in, and it reaches the database that we have over here because we spun up multiple databases, that information is not going to be over here, and that's why you need kind of one master node. And so you can only write to the master node usually. That's usually the only thing that can get written to. So what we have is this master that we can read and write to. So Jimmy, if Jimmy needed to sign up and Sarah needed to sign up, all their signups would go here. It would get written to this server, and then those changes, those rights would get propagated out to all of the other nodes. So we have a bunch of replications, we have a bunch of copies of the master node, and eventually that information will get copied out to all of those, and then then we could use those to read from. So all the services that are getting information could go to any of those services to get the information, but things that are writing to it could only write to this one. And it's a pretty interesting paradigm that exists in a lot of services. And it's a good way to manage data and to make sure data is is resilient and doesn't, you're not missing data anywhere. So we have that set up here, and then we're going to create the Redis master deployment. So we didn't go over deployment, but a deployment, let's skip over. I feel like I made a slide for deployment, but obviously I did not. But what a deployment basically is a deployment is we could run through right now, and we could deploy pods. We could deploy services. We could deploy all these things by ourselves. And you could use that to manage your Kubernetes infrastructure, but that's not, especially in large scale applications, it's not really a good way to manage what you're doing. It's not a good way to manage what you want to do. And actually, you know what? I actually think I meant to do this. I actually think I have some notes on this, just so I don't miss anything. But before I pull the notes up, I think with the deployment, you can really manage the things that you're doing. You can kind of define a deployment, and you can use that to be able to manage all the things that you want to do around an application. It makes it easy for you to do things like update versions. It makes it easy for you to do things like roll back, and it makes it a lot easier for you to manage a set of applications that you're trying to deploy. Let me see if I can find here what I was going to make a slide about. I thought there were some important things that I wanted to boil down into it, but I did not put them in here. Maybe I do not, but we'll go through a deployment in a second. But it makes it a lot easier to manage your things. You should be using deployments. 100% you'd be using deployments especially when you get into an enterprise setting or you're working with your organization to deploy things in Kubernetes. You should be using deployments because it makes it so much easier to manage and control that infrastructure and know what's going on. And it allows Kubernetes to do a lot of that work for you, to do most of the work for you. So let's go back over here. And so it looks like the first thing we're going to do is create a deployment for our Redis master. And so, so they call them manifest files. I wasn't sure about that, but the manifest file included below specifies a deployment controller that runs a single replica Redis of master pod. So this YAML right here, and maybe we'll grab this and maybe we'll throw it into Visual Studio Code really quick so you can see, just so you can see what it looks like, and we'll kind of break it down. And you can see what you're looking at here. So let's go back here. Let's go into VS Code. Let's go into documents. Let's make a directory for what are we doing today? Kubernetes. I don't feel like typing that out. So K8s, and we'll go into Kates, and we will vim Redis master dot YAML. Actually, not vim. Code. We'll open up Visual Studio Code right here, and we're in the K8s directory, and we'll create a file called Redis master.yaml, and it's probably a Kubernetes extension we can get. So let's see if we can get it really quick since it takes no time to do so. It might just be the Docker one. Let's install the first one. I don't know if it's good. It's got a lot. You can see here it's got a lot of downloads. It's got 5 stars as well. So let it install really quick, and we'll see if we get anything cool out of this. taking longer than it should take, so maybe this is big. But while it's installing, we'll see if that actually gives us any extra stuff. Okay, it looks like it gave us a little bit, but we'll save this. Let's close to the side. All right, so we've got a couple things here. So API version, this is going to be the Kubernetes API version that we want to use. As this becomes, as this grows, and the API version changes, we can change that here to specify which one we want. But this kind line right here is pretty important. So kind ends up being things like pods. Let's say you want to deploy a pod. You can see here how VS Code will fill it in for me. We can say, whoops, I shouldn't have done that pod, or you can make it a service. So you can do a lot of stuff like that. A replication controller. So you have a bunch of options. These are these Kubernetes objects that I was talking about. But we were doing what are we doing? We're doing a whole deployment. And I'll show you how we can read that once this is out. So we have a little bit of metadata here. So we have things like the name that we want it to be. Metadata is just a little bit of text information about the application. Metadata is used for a lot of things. It's just a little bit of extra data that is a part of it. So we get a label here, app Redis, and then we get a bunch of stuff. We have a bunch of stuff in here. We've got labels, match labels for different things. We have roles, tiers. Ignore that stuff right now. There's tons of options in these manifests. I'm actually going to show you a simpler manifest a little bit later. You don't need all this stuff, but yeah, it's a deployment. And we talked about replica sets. So replica meaning one, and so one important thing to know about replica sets is that if you just deploy a pod and you're not using a replica set, if that pod dies, remember how I said Kubernetes would keep things up, and you say you want one and it would keep, you want 10 and it would keep 10 up. If you do not use any replica sets, when it dies, and Kubernetes doesn't do anything about it. So if you want an application, even if you're just running one pod, and you want it to stay up, you need to be able to deploy that with replica sets, and as long as you specify one, Kubernetes will make sure that one is always up and available for you. So you'll see that often, but you'll also see where there's no replicas, and that might confuse you. Like, why would you put one, and why would you not put any at all? So that is why you want to do that. This will make sure it's up and available at all times, no matter what. And then just more metadata and more like little information about what we're doing, and then this is where we get to a piece that's very Docker Compose-ish. So we did all this, but we're running containers here. So Kubernetes is running Docker, running containers. So we've got to define what containers we're deploying here. So we talked about container images, and this is saying, hey, go grab the image K8's GCR IO Redis, this one. So it's really Redis. This is the tag. So this will be latest. It was just like this. But this is just a specific container, and the reason this is here is because we're grabbing from a different Docker repository. So this one is not coming from hub.docker.com. This is coming from this address instead. And this is Google's container registry. And again, they're using Google because Kubernetes came from Google, so they probably use this registry for a lot. But you can that's where it's going to grab it from, and that's just the setup for that. So it's going to pull it from Google. It's going to pull an image that's already pre-built. So we don't really care about that. Redis already has an image inside of Google that's pre-built, and it's going to pull that for us. And then it's going to set it up with, we'll give it some resources and things like that. And then we'll expose some ports for it. And we'll tell what port it's going to run on and the ports that we want to expose. So very, 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 very simple. I won't say very, very simple, but there's actually, like, you could remove a lot of the stuff. The metadata stuff's not essential here. But yeah, it's for the most part, it's actually pretty simple. You don't need to know YAML right now. Just get comfortable seeing it. Know that it's just a way of formatting data. Know that it's a superset of JSON. So when we think of JSON, YAML is kind of the same thing. It's kind of a next level. I do believe that all I don't know which way this goes. Either all JSON parsers can parse YAML, or all YAML parsers can parse JSON. It's one or the other. I don't really know which one it is. I can't remember. But they are. This is a superset of JSON, so it's probably all YAML parsers can parse the JSON. That's probably what it is. But yeah, so we have this here, and they gave it to us. So don't sweat that. You don't gotta type that out. All right. So gave it to us, but we didn't really need to grab it. So we could use this to deploy our first Kubernetes thing. So it says launch a terminal window in the directory that you downloaded the manifest file, and apply the Redis master deployment file. So I could call it whatever I wanted. If I downloaded it, this is what it'd be called. But we copied and pasted it, which is fine. But what I thought was interesting here, in the actual example, they give you this -f, so the -f allows you to specify the file that you're building off of, and this kubectl apply command looks like it allows you to pull from a remote from a file from the internet. So it looks like it's grabbing it straight from the internet from this URL, which is very interesting, which is pretty cool. But so if you don't want to copy and paste that file, you don't have to. It looks like this will work. I never tried it. Actually, I just want to try it because I don't know if it works. Maybe I'm wrong. So we're gonna go here, and we are going to, let's actually move this one down. So now we have 3 screens. All right, cool. Go paste that right in here, and I'm gonna go ahead and hit enter. So actually, before that, let's see what kubectl apply does. -- help. Let's see if the help will give it to us. Okay, it does. So apply applies a configuration to a resource by file name or standard input. So basically it's going to apply a configuration that we pass to it. So this YAML is that configuration that we're passing to it. And it's going to do it by file name. So the -f says, hey, file name or standard input. And so I guess we can pass it in via standard in. We might not have to deploy. Yeah, it's probably a way for us to kind of throw that into standard in. Probably something like catting that file and piping it in or something like that will probably work. Never done it that way before. Always done it via file. So let's see what happens when we hit this. All right, so we can see here very quickly, it spit us out some information, and it says deployment.apps Redis master created. So it's very quick that it did that. And we can use our kubectl command, and we're gonna get deployments because we wanna see what deployments we have. So it's still spinning up. It doesn't look like it's out yet. There is a command to check the status. What is it? Is it rollout? Rollout status. And then I think it's deployments. That app's not found. What do we call this? Redis master. It takes a while to get up to speed with these kubectl commands, but you can use kubectl to find out all types of information about your stack. So this rollout thing, as it's rolling out deployments, you can use this to find out what the status is of a deployment. So like in a large scale organization, your Kubernetes clusters may be very large, and you may be deploying lots and lots of things. So this may take some time. So you need to find ways to check the status. You need to find some ways to monitor it. There are some other ways to do this, but this is a command that you kind of have available to you to kind of know what's going on. And it says waiting for deployment Redis master rollout to finish. That is still going. So let's see what other options we have while this is doing that. So get deployments. And so you can see here, you can also check from here, it says 0 out of 1, that's ready. So that is not ready yet. What happens if we get let's see if it's creating any pods or services. So pods, you can see it created a pod here. So that's still spinning up, and you can see the status is that it's creating. Container is creating, and I think we can actually do, I think if we do describe this, I think it'll tell us describe pods. The server doesn't have resource. Oh, that was dumb. Describe. All right, so you can see here, if you do a describe on it, even while it's spinning up, it'll give you some information about it. It'll give you a bunch of important information that you may need. But right now, we're not gonna worry about that. It's just know that you can get that information. This is the same thing. If you're dealing with AWS heavily, they use the describe keyword to get information about resources. So does Kubernetes. But you can see here, it'll tell you everything that it's doing. So it shows you here that it's pulling the image and that it successfully pulled the image and that it created the container and it started container. So we're probably good to go here. So if we get pods again, you can see here we have 1 out of 1 that's ready. So we have a whole pod that's ready. Let's check our deployment again. So when the deployment's done, it says Redis master successfully rolled out. So all that's a little bit of extra things that I gave you about how to kind of manage. These are like little tools to help you manage your cluster and to know what's going on. So get comfortable with some of these kubectl commands because they do come into play a lot. You do need to know how to get information to figure out what Kubernetes is doing. Kubernetes does a lot. You need to know how to figure out how to get that information out. Again, not important that you know for sure at the end of this how to check all this stuff, but I just want you to see that you're able to get all this information. There are commands to get all types of information. So if you're ever like, hey, I don't know what's going on, know that there's some way that you can Google it to get the information that you're looking for out of Kubernetes. Kubectl allows you to get that information. And I think, did it spin up a service? I'm pretty sure it spun up a service. It did not spin up a service. Okay, so we did the first piece that it said here. We ran what they had here. We actually didn't save the file. We didn't need to save the file. We used this -f. And again, that's something I learned today. I did not know this could take in an HTML or a web file. That's pretty cool. So they tell you how to do these things as well. Kubectl get pods to make sure that we can see that Redis master is running. And again, what are pods? Think about, like, as we're going through this, think about what pods are. Pods are that initial, that lowest level of capacity that we're talking about. That is 1 or more running container, and our pod is running Redis. Yeah, our pod is running. We have 1 pod that's running Redis. It's our Redis master. So we can also do this, kubectl logs. So we can get some logs from this. So actually I should, let's see, kubectl get pods, and then kubectl logs, what was it, -f. And we can get some logs from it. So as the container spins up, we can see what's going on. We can get the output, and we can see here that this is the Redis version, and this is the log. This is what Redis is outputting, and let us know that Redis is running in standalone mode on this port. It's PID number 1. Remember, this is a container. Containers are designed to run run process. PID stands for process ID. It's the first process, which is pretty cool. And it lets us know the server started, and the server is now ready to accept connections. So it looks like Redis is up and running. We use that to check the logs, and it looks like their walkthrough so far is going pretty well. You know, we can use that to get information. So there are logs for the containers here. So, and control seeing that doesn't stop anything. Everything is still running. So now we need to pay attention to the words that they're using. The words are important. The first thing we did was create a Redis master deployment. So we created that deployment. Again, I told you this is a big thing that makes it easy for us to be able to manage the application as a whole and to be able to make changes to it. And it gives Kubernetes some extra functionality over top of the things that we're doing. Makes it easier to do things like rolling back. Makes it easier to do things like, you know, updating the version, things like that. The next thing it says down here that's going to have us do is going to have us create a service. Services are something that we went over here. So service is, you know, is a set of pods that work together, such as one tier of a multi-tier application. So yeah, so now we're going to define this service. So deployment is different from a service, and we are going to deploy this service now. And so we can see here, the service is actually a lot shorter. So let's read what the service is for. The guestbook application needs to communicate to the Redis master to write its data. So there needs to be some communication that happens here. You need to apply a service to proxy the traffic to the Redis master prod. So we have to create this service to allow the traffic from the guestbook to get to the Redis master node. And that's what this service is going to allow us to do. A service defines a policy to access the pods. That is what services are. Perfect. You said it perfectly. Go React.js. It is the middleman here. That's all a service is. And so we're going to set up a service. So take a look at the YAML here, and let's copy and paste it into VS Code so we can, take a look at it with some colors, color coded. It gets a lot easier for my brain, at least, to take a look at these things when they're color coded. So let's create a new one. Let's call this Redis service.yaml. And remember, YAMLs are just YAML files, and JSON is just key value pairs. So just kind of have this key over here and a value, and the structure, the indents is the structure, and that determines what's nested under what, things like that. Little things like this are for arrays, etc. You have some other options in there, but yeah. So this is a service right here. So again, kind here is a deployment. We have a deployment over here in the Redis master YAML when we were doing a deployment. Right now we're deploying a service. The kind that it is a service. Really great. So metadata, very simple things here. Redis master labels, these are just things that help us to be able to, you could use these for things later, but they're also helping us to identify what this is and to be able to, filter it, etc. And then these are the specs, ports. So the service allows proxying. So we want port 6379 to go to port 6379. And then we want to select the Redis master backend. And remember, these are the labels that we actually gave over here. So it's going to be able to find this. It's going to be able to find this thing via the selector here. And it's going to use that to proxy these ports basically. So let's go ahead and deploy this service, or see what they want us to do next, which should be to deploy the service. So apply the Redis master service from the file like the following. So same exact thing. This kubectl command, apply command, and a path to the file. So the file is actually, we're gonna grab it straight from internet. And here we go. Let's run that. Let's actually clear it. So another quick, I'm gonna try to give you all the quick Linux commands that I know. You see me type in clear a bunch of times to clear the screen. You can also just hit Control L, and that will clear the screen as well. It'll just push everything up really, but it'll clear the screen as well. A pretty quick shortcut. But we'll paste in what we have here, and we're gonna apply this new Redis master service. Now it's a service. And just like that, really quickly, it let us know that the service was created. So what command can we use to see our services? Kubectl get. Remember, get is how we see these things. And we'll type in service. And we can see here, before we only had this Kubernetes service, the one that was set up by Minikube. And now we have this Redis master service. And lets us know the port that we were talking about here, lets us know it's 13 seconds old. We can run it, and it'll tell us how old it is, which is really nice. So we have this service now that is set up for us. So that is great. And again, they tell us here, kubectl get service. Remember that get command is how you kind of get information about what you care about. So very simple. Now we have this service set up. We have this proxy that will allow us to access this. Looks like we're getting around the halfway point, so this is good. So now we have the master. The master's all set up. We have the service in between it, so we can actually make requests to it, and we can contact it. And now we're going to start up the Redis slave. So although the Redis master is a single pod, you can make it highly available to meet traffic demands by adding replica Redis slaves. So again, high availability. If you want to serve a bunch of people, serve a lot of requests, you need to throw more power at it. You can make more Redis basically servers for those requests to read from. So we're going to go ahead and do that. So now, again, the words matter. We're going to create a Redis slave deployment. So we're going to create another deployment with one deployment already, which is the Redis master. And now we're going to make a Redis slave deployment. And it lets us know here that deployments scale based off of configuration set in the manifest file. We talked about those replica sets. So the deployments object specifies 2 replicas. So it looks like here, the amount of replicas here are 2. So it looks like we're gonna have 2 options here. We can mess around and change that number, but we're gonna use 2 at first, and then I'll change it. I'll scale it up and scale it down so you can see how that works here. So if there are not any replicas running, if there are none running at all, the deployment will start with 2 replicas on your container cluster. Conversely, if there are more than 2 replicas that are running, it will scale down until 2 are running. So if we had it set to 10, and then we redeployed with 2, it will scale from 10 down to 2. So it looks like this is a little bit longer. And let's copy this one, and let's take a look at this one and see what we have different here and talk about what those things are. So let's go over here and save this file. And now for the service, let's create a new file and call this Redis slave deployment YAML, and paste this in, close this, and see what we have here. So we've got a lot of the same stuff. So you can see this kind of happen over and over again. We can see here that we also have another deployment here. It's got a different name because it's not the master anymore. And then we can see here the replicas before for the master. The replica is only 1 because we only want 1 master, but we want 2 slaves here. So we have that set to 2, and then we've got a bunch of the same stuff. Same thing, it's going to pull a different container here than we had before. We've seen this as well. And then we have this env section. So this is where you set your environment variables. And so there, it gives you some options here to change things if you'd like. I don't think we have to change anything right now, but it gives you some options. It gives you some stuff to read through if you want to change the way that works. And then the rest of this, looks the same. Most of this, besides this env section, looks the same. So let's go ahead and probably just deploy this thing. So our app seems like it's coming together. So actually what I want you to do after all this, we're gonna deploy this whole thing. I want you to try to go, just if you've never installed Redis or mess with Redis, go try to see if you can manually install a Redis cluster, a master Redis with some slaves, and see if you can do it manually yourself to see how wild, or not wild, but see how much longer it takes and see how much more cumbersome it is than what we're doing now. But then maybe that's for later. Let's go ahead and finish running through this. So we've done this a bunch of times now. We're gonna go ahead and just install this file or apply this file. And just like usual, it happens pretty fast. And let's see, what do we want to get? We want to see kubectl, get deployments. And you can see here we had a Redis master, now we have Redis slave, and you can see here it's not spun up yet, but it's on its way. And let's go ahead and get pods. Let's see what kind of pods we have set up. And so here with the Redis master, we only set up 1 Redis master. That was the replica set that we set up. We set up 1 replica there. But what we have here now is we have 2 different Redis slaves. We didn't do any work to set them up. We said we want 2, and 2 are spinning up now. So they're still good. They're still creating. And again, we could do logs -f. The F just allows you to continuously see them as they come out. Grab this. Uh-oh. It's waiting to start. So it hasn't, okay, there we go. So just like that, just that fast. There's some changes that were made, and it finished kind of spinning up, and we're looking at the logs for this container. So yeah, so it lets us know it's doing all this stuff, and it lets us know that it connected to, basically it was able to connect to the master. So full resync from master. Oh, master replied to ping. This is great. This is excellent. We didn't even have to do anything, and it connected the master to the slave here, synced them up, and it's doing all that right now. So that's pretty great. This is actually pretty fun for me because I've never set up a Redis cluster like this with Kubernetes, and I've set up Redis clusters before, and so this is pretty exciting for me at least. So we can see those spun up there. Now we need to create a service here. So we created the service for the master. Now we need to create the service for the slaves. This looks very similar to the one for the master, and let's go ahead and apply that. We don't need to take a long look at that. So the service is created. Again, how do we see? What command do we use to get information about what we're looking for? And so we'll get information about our service. And now we've got the master and we've got the slave. The slave one wasn't there before, but we're all good. That's spun up now and looking good. So it says query the list of services. We're always a step ahead here. So we've already queried the list of services and we know the services are there. So we have basically, we have our main backend, I guess, for this application that we're going to be running. And I'll stop there for a second. We have we've set up now this in-memory database, this in-memory caching layer service here with a master slave relationship. We did it pretty fast. We were able to run, basically we ran 4 commands, and because we had it configured properly, because these manifests or these YAML files are set up accordingly, it was able to set those things up for us and get them configured how we wanted to get them configured. And they're all using Docker containers. You can see here in the deployments, we're specifying these images. Remember, these images exist in these public repositories. The images get pulled down and they get deployed. You can deploy any image that you would like. You can build your own images. You can use any of the publicly available images you like, and everything is good to go there. So the pods could have multiple containers running in them. Correct. Pods can have multiple containers running in them. A pod is just a grouping of containers. Perfect. Same pod of wells. Those a group of similar containers inside a namespace. Perfect. Absolutely, that is absolutely right. It gets a little, I think one of the biggest problems with Kubernetes is because of the amount of different pieces of it. When you start talking like that, when you start like going through it like that, people start to get a little confused about the different pieces we're talking about. Like, oh, now we're talking about namespaces, now we're talking about pods, like all that stuff. But that's exactly what a pod is. Usually pods is a group of similar containers inside of a namespace. Yeah, hopefully it's very hard to simplify those explanations more than that. I think that's perfect for sure. Yeah, so all you're doing is, I wish they did these without all the metadata, even though we need the metadata to do some of these selectors and stuff that we're doing here, but like they get a lot simpler than this. Like a hello world one or something like that would be a very simple manifest here. And again, you don't need to, everyone's like, I've talked to people who are like, oh, like I could never write anything like this from scratch. You don't need to write anything like this from scratch. It is perfectly okay to take some kind of example manifest and modify it accordingly. If you want to deploy an application, even if we were doing WordPress the other night, change the name of this. We don't want it to be Redis slave. We could take this and change this to WordPress. And we could change the label to app WordPress, and the selector we could change something WordPress, role, CMS, or whatever you want it to be, tier, front end or something like that, or tiers. Again, CMS. You can make it whatever you want. This metadata and is for you. It's for your organization, and for you to be able to use to select different things and to find different things. But it's all when you hop in and you get going with it, it's all actually fairly simple. It's configuration. It's not, don't think about it like coding. You're not doing a lot of logic here. You're basically you're configuring things. You're giving values to things, and sometimes you have to think about that in a very abstract way. But you're configuring things and setting them up the way you want them to be, and you're providing this information to Kubernetes, and Kubernetes is taking that and making it so. It's making it a reality. So that's the fun of this. All right, so let's move on. We don't have a ton of time left. Let's move on and see if we can finish getting this set up. Let's set up our front end here. So set up and expose the guest book front end. So again, words are key. Exposing is key here. One of the first things you'll do if you try to go through, there's a very cool Kubernetes training course on Udemy. You usually can get it for like $9. Wait for it to be $9 before you buy it. But it's like the first one that comes up. It's just like tons of people enrolled in it. But he goes through. He's got a repo. He's got some like Hello World apps from there, and it shows you some different ways to expose it. One being the proxy. Being a service, and then you can grab, basically, once you expose a service, you can grab a URL through Minikube and see that thing. But you can also, there's also a kubectl command to be able to expose ports temporarily, to be able to see these things as well. But exposing guestbook front end, means actually exposing it outside of the cluster and allowing other things to be able to gain access to it. So set up and expose guestbook front end. We've done the back end, or kinda, so let's do the front end. The guestbook application has a web front end serving the HTTP. So we know HTTP stands for a hypertext transfer protocol, and that is the language of the web. That is how, that's the protocol of the web, and it's responding to those requests that are written in PHP. It's configured to connect to the Redis master, so it's already configured, it sounds like, to be able to connect out to our Redis master. Service for writes and requests, and the Redis slaves for requests. So it's already set up to be able to, this application is already set up to be able to use the backend that we've created for it. So creating the guestbook front end deployment. So it looks like we have another deployment here. And again, look how similar this is to the ones we've already looked at. There's nothing special here. Besides the labels, really. Now we have an extra replica, so now we have 3. So you can see here, you can choose whatever number works for you. There's no right number. It's the number that works for your setup and serves your clients the way that they need to be served. And then again, just more labels and changing those to reference this. And then we're just choosing a container. And so we're calling it PHP Redis. That's the name of the name of the container that we're going to be running. Well, this is the name of the image that we're going to be running, but the name of the container is going to be PHP Redis. And we're going to grab this image here that's already been pre-made for us, which is great. And then the same thing gives us some resources and allows, for a certain amount of resources. And we'll get a lot of the same environment variables here and the same ports. Remember, port 80, that's the port that the internet runs over, that HTTP runs over, is port 80. So we're gonna go ahead and do that. The PHP, the front end, I believe, is just PHP and HTML. Yep, I think there's a PHP interpreter in here, and it's just PHP and HTML. So let's go ahead and let's apply this. So now, again, remember what we're doing. We're doing a deployment as opposed to a service, as opposed to a pod. So let's go ahead and do another deployment. So we're setting up a deployment now for our front end. Let's apply this, and again, let's do our kubectl. We're gonna get deployments because we want to see our new deployment since we just applied a deployment. And now we have another one added. So we have master that we already had. We have slave that's, running here, and we have front end. And remember, what's the command we can use to see the status of our deployment? We can do kubectl. I never remember. Rollout, status, deployment, front end. I think I always get it wrong, but I got it right. So it's still waiting, and so you can just watch that and wait for it to finish if you want to watch and know the status or something like that. But yeah, you can use that. We'll go ahead and let that finish. Keep watching that. Let's check our nodes and stuff and see all of our deployments so far have kicked off some pods, which makes sense. So now we have some pods here, and remember, we see 3 here. And why do we have 3? Remember, if we go back to this, we have 3 replicas. Very simple. The amount of replicas you want, that's the amount of pods you're going to get here. So we've got 3 here, and they're still spinning up. Let's give those a few and take a look at how much more we actually have. So then we have to do a service, and then, okay, cool. I think we'll be able to finish right on time. I'm actually surprised. This is actually for not having gone through this, this is a pretty good application. I tried to build this like really cool like web app thing to do through this, and it wasn't working for me. So I was going to do some Hello World stuff. I built some Hello World stuff for this, but this seems like it's a little more fun, to be honest. It seems like we're gonna get something cool, I hope. Get pods. So these are still spinning up, and so I can actually remember I can do if I want to know what's happening. If I'm like, hey, what's taking these so long to spin up? You know, I can copy this and I can do a describe instead. And I can see here it's pulling an image. That's why it's taking so long. It's got to go and it's pull that image. I don't know how large that image is. If your internet's slow or anything like that, that could delay it. But now I know, at least I know what's happening. I can find out what's happening with this pod, which is really, really nice. And it's a good way. It's a good way to be able to keep an eye on that information, because half of these jobs are to be able to gather information, especially when something's wrong. Is like gather information. So use all your tools, and a lot of the things that I'm showing you now are how you gather information. Remember, get, describe. These are how you get information and know what's going on, and then you can use that information to make decisions. And even if you don't know how to fix certain things, it allows you now to be able to Google stuff. So you can say, hey, like my Kubernetes pod won't deploy because the image has been pulling indefinitely, and maybe you'll Google like indefinite Kubernetes image pull, and maybe you'll get an answer of like, hey, that just means check your internet, make sure your connections can reach out to whatever container repository you're using or something like that. But the information is key, and being able to get that information is key, and you can like that information is what you use to solve problems. So you need to get good at gathering information and knowing how to like figure out what's going on. Like even if you don't know Kubernetes well, like if you can learn how to get the information you need, you can get there. So that's still pulling. That'll probably take a while. I could probably watch this. I wonder if I can do a -F here or something. Nope. Let's try just trying some things to see if I can watch it without hitting it. Watch probably won't work. I didn't think it was gonna work. All right, we will let that finish. Does anyone have any questions while this is going? Because everybody is streaming YouTube at work. Yes, this is so. That is not a you making that statement is actually not a. That's the thing that happens. I know of an organization where their internal internet was going very, very slow, and when they were figuring out why, it was because everyone was streaming Netflix, and as soon as they blocked Netflix, the internet got faster for a little while, and then slowed down again because then everyone started streaming Hulu and Spotify, and so they had to slowly start breaking things down to figure that out. But that is not an uncommon thing, because everyone at work is streaming YouTube because they need to find out answers. I can't tell you how many times like I'll end up, I'll do my best to find things through Stack Overflow and through official documentation, through GitHub issues and things like that. But sometimes I'll just have to, if it's something I don't know how to do, I'll have to watch a good old video on YouTube to be able to learn it. So you get in a weird state there. Cool. All right, so we have this is running now. See here. Let's see what the describe tells us now. Even though that it's done, lets us know that it's successfully pulled and everything is running. Created the container, started the container. Everything is good there. So now we have our front end. All three front ends look like they're up. If we take a look at the pods, looks like all three front ends are up and running. And let's take a look at the logs for those. So they've come up now. How do we see? Make sure they're good. So cube cuddle logs. I don't really need the -F, but I'm gonna do the -F. Again, the -F just kind of tails everything. So cube cuddle. I'll show you the difference between the -F and the not -F. All right, so it actually looks like that failed, which is interesting. Could not actually though. This is generally a problem when Apache first spins up. Apache is a web server. Could not reliably determine the server's fully qualified domain name because we don't have a host set. And then it looks like, this is just a notice. So it looks like it's just running. Work notice. All right, so it looks like it's up, I guess, but I don't know what it's doing. But do it without the F. I believe this is what it does. But do it without the F. It just, you can see here how when I ran it with the F, it basically tailed the log indefinitely. So it's just looking at this, it's waiting for changes. If there are changes to the logs, it will update. This is a common paradigm with when you're trying to see what's going on with logs. Even if you're just checking like a system log, when you add the -F, I don't know what it stands for. Maybe we'll look up what it stands for. But it kind of indefinitely tails this, and as updates come in, it'll spit them out. If you don't have the F, you can see here how it drops me directly back into the command line. It gives me what it has, and it drops me in the command line. Perfect. Learn something new. F stands for follow. That is great. F for follow, very simple. And you can use that as a troubleshooting tool, especially when you're parsing logs and trying to see what's going on. Passing in a -F follows that, and you can see all the updates as they happen. Cool. Thank you everyone for that. I knew as soon as I said it that everyone would have an answer for me. I appreciate that. I feel so much smarter. I was going to work. I'm like, hey, I learned something new on the stream today. I cannot tell you how many times I've used :X in Vim. But there's been a few other things that you guys have taught me on here that are like, I've gone immediately the next day and I'm like, I'm smarter than all of you. I learned some dope stuff last night and now I'm going to show you. So I appreciate that. Cool. So now that that's up, let's see what it wants us to have us do next. All right, so query the list of pods to verify that the 3 front-end replicas are running. So let's copy this command and we'll break this command down a little bit. All right, so basically all this did, and this is why that metadata is so important. So let's clear this so there's no extra cruft on the screen. But we did the same command that we know, kubectl get pods. And then we were able to use this -L to go through our metadata. So we're looking for things that are tagged basically as app equals guestbook and as tier equals front end. So we were able to use that metadata, the metadata that's here. You see these labels here. That's what the -L is for, to check labels. And you can see here we were able to use that information to be able to filter and to be able to grab that stuff. So that's what those things are for, and it makes it easy for you, to be able to find what you need. So you can see here now that it filtered this list down to just the 3 items we care about, and not all of them, like we would get if we did without those filtering options. So now you can see why this stuff is important, but it's not necessary. It isn't necessary, but it does help you when you get further along, and it does help you. You need those for the services. You need those for services as well, but that's just what we have here. So I'm glad they added that in there. All right, so now we need a front end service. So for all 3 of these things, we've created a deployment, and then we've created a service. That service is to basically set up proxy connections, set up that middleman connection, so that we can actually access what goes on in our deployment, access those pods that get deployed. And so our service allows us to retrieve that information. So the Redis slave and the Redis master services you applied are only accessible within the container cluster because the default type for a service is cluster IP. Cluster IP provides a single IP address for the set of pods and the service that the service is pointing to. This IP address is accessible only within the cluster. So basically, the way that we have this set up is that it's using a cluster IP to provide the services, using that cluster IP to provide an IP to it to provide a way to access it, and the IP that it gives it is only accessible from inside the cluster. If you want guests to be able to access your guest book, you must configure the front-end service to be externally visible so the client can make a request to the service from the outside of the container cluster. Minikube can only expose services through node port. So this is something that is specific to Minikube. Minikube can only expose services through node port, and I'll show you what that is in a second. And so generally when you get out of this and you're using like AWS or something, you'll be using load balancers to handle all this, but we're going to be using a node port for this. So this is the service for our front end, and we can see here that we're now going to be doing type node port. So internally, our services are using Internally our services are using that what was it, something IP, cluster IP, using cluster IP to do it. And now we're using a new method to do that for our only for our front end. So all the Redis stuff is accessible internally to the cluster. That doesn't need to be available external to the cluster. So that's important. You know, we're implementing the path of least access here. You know, people only need access to the front end, so we're going to give access to the front end, and everything inside of the cluster, you know, just has access to each other. So let's go ahead and deploy this new service that we have for our guestbook front end that is now using node port instead of cluster IP. And you can see here, the more and more we talk about, the more and more like options and things that there are. This is why it's so tough. Like, there's so many different options and things, but again, high level is what you care about right now, and just understanding what Kubernetes is doing. Like, we're just managing containers right now at scale, and so you can see us just doing a couple containers, but we could easily be putting in hundreds of containers, thousands of containers if we wanted. And that makes us, like, that's very easily, that's it. We're doing this in an easy way. We're not running 1,000 run commands. We're not writing out this weird script that like loops through and runs 100 containers. We are using the tools available to us to deploy lots of containers at scale. So we created a new service, and as usual, we're just gonna verify that our service is up and running. So get service, and now do we already have front? Oh, we have front end now, but our front end is no port. So you can see here all these that are internal are cluster IP. So that, like, only things inside of the cluster can access these services. But our front end has no port. So now we can access this from outside, or we'll be able to access this from outside. So get services, we saw that, and it's very important that we saw the node type is node port. Now, how do we view the front-end service via node port? So if you deployed applications via Minikube or to a local cluster, you need to find out the IP address to view your guestbook. So to do this, to get the IP, we actually have to use, go back and run a Minikube command, actually. And we basically use Minikube to query the service URL for front end. So you can see here, we're using the Minikube command, and then we're passing in a service. We're looking for the service. And the service name is front end that we care about, and we're gonna look for the URL. So this is something that's specific to Minikube. You can always Google how do I find the URL for a service in Minikube, something like that, or type in Minikube URL, it'll pop up. It's a common thing. And so we're gonna type this in. The reason you've got to run this and you've got to go through this is because one, the way that VMs do networking on your system, this is running inside of a VM, so you can't just hit localhost, because this is, you know, it's running on a VM, it's not running on your computer. So you have to go in and you have to grab what the URL is, and this is just the IP address for the VM that I'm running, and it gives us a random port here that it kind of proxies it to, and we can go ahead and plug that into a browser here. And we click that in, we have a guest book just like that. So we have a whole application running just in a couple minutes. And so let's see what else they have us do. If they have any more, we can play around with this. And so this just lets us know how to do it if we have a load balancer. So if you're using a load balancer instead, you just do that a little bit different. And then, so we're gonna scale this in a second. We're gonna talk about scaling, gives us a couple other options, but let's mess around with this really quick and see how it works. Message, I don't know, test, submit. And so our guest book, you know, it is like at your wedding, if you know, people come in and they want to sign in, that's my name. And all right, so we have a cool, our application, all it does is it's a PHP HTML application that basically just has an input box, takes our message and I guess throws it in the div, or throws it in a list here on the page here. So very simple application, but it's an application that's up and running. If we refresh, it should still be there, mostly because of Redis. If we destroy the Redis cluster, this stuff would all go away because it's in memory stuff there. Cool. So that's pretty cool. We got an application up and running. It's a weird application. Maybe I can find a better application next time. But what else do they have us do here? So they let us talk about scaling the web front end. So let's say a bunch of you, let's say I was able to open this up to you. So I can't because you wouldn't be able to hit this IP address because this is a IP address that's local to my machine because of my networking for my virtual machines. But if I can make this available to you, let's say all of you all started hitting this IP address. If my computer couldn't handle that, or if these containers kept dying because you guys were overrunning it, we could easily scale this stuff up. So we have this all out here, but I can give it some quick commands to be able to very quickly and easily scale up. So scaling up or down is very easy because you define services that use deployment controller. So this is enabled because we've used that deployment controller, and we can run this following command to scale up the number of front end pods. So this says 5. We're gonna go ahead and give it 10. Just because 10 is a cooler number to me. So 10 replicas. And just like that, it says, hey, this has been scaled up now. And so if we do a kubectl, get pods, we should now see 10 items for front end. And you can see here, they're still spinning up. So this one was already running, this one was already running, this one was already running. We had 3 before, and now we have all of these pending options because now they're getting ready to start. And then so now we will have 10. So it created 7 more of these for us. And so, you know, just as easily as we did that, we could drop it back down to 2. And it'll let us know that it's scaled. And you can see here, all of these are terminating now. So before they were creating, now they're terminating. So you can very quickly, you know, because we use deployments, you can very quickly just say, hey, this service that we're using, I want way more of these things. Like, you know, we're dying over here. We're like, our containers are getting overwhelmed, but we have a lot more space. These allow you to horizontally scale. So we talk about vertical versus horizontal scaling. Vertical scaling is throwing more resources at something. So you have a server with 2 CPUs and 16 gigs of RAM, and to scale up, that would be like, now you have a server with 4 cores of CPU and 32 gigs of RAM. So getting bigger that way, but scaling horizontally is just throwing more of the same item at it, throwing replicas of the same thing at it, throwing more services at it. So now we're just giving more and more containers, so we can scale horizontally very, very easily with deployments and Kubernetes. Like the deployments are what allow us to do this so easily. So I'll set this back to 3, and some are still shutting down from the ones that we're trying to spin up. But yeah, you can see here, it gives you, kubectl gives you a very simple way to use the paradigm of deployments to be able to scale up and down the pods that you have. And that cleaning up. So now we can just we can clean up everything. So we've deployed everything pretty easily. And now again, this all goes back to our infrastructure as code stuff as well. Because these were written, you could save all of these manifests that we wrote here, or that were given to us. You can save all these to their own individual files and have them available to you. And then what you could do is, you wouldn't care so much, you know, if you're doing development, you don't really care. You don't want this infrastructure running at all times. You don't need it running at all times, because you've codified the way that you want it to be. You've codified the way that you want it to work, and you can just go ahead and run these again to spin it back up anytime you want. If I wanted to spin this up pretty quickly and we weren't running straight through this, I could do this probably in just a minute or 2 and get all of these services, all these applications spun up, and have this entire application that is scalable, this entire application that is fault tolerant, spun up very quickly. But it's easy to spin these things down. So we can just run through and delete all of these things, delete all these deployments. And so let's clean up everything. So I'll go through them all first. So it's going to delete that deployment. We're going to delete the 2 services, and we're going to delete the 2 deployments. Oops. Probably should have waited till that was done. And what's the last one? And give that some time. And kubectl, get pods. Probably gonna be terminating some stuff. What do we miss here? What do we delete and what did we deployment apparatus service apparatus? These should be got some stuff terminating. Maybe I didn't delete everything. But yeah, it's a pretty simple way. Let's see. I'll run through and make sure I did all these. But you should see everything getting deleted. And when you get to here, it should say no resources found. I might need to run through and give it some time. But I also might have skipped one of these. But also, so the reason we're only deleting 2 services here, it's because we set up 3 services actually, 3 deployments, 1 for the front end. The reason we don't is because 2 of them, the label app Redis was set, so that should cover both the Redis master and the Redis slaves here. And so let me just make sure that is okay. And still, what's it doing? Okay, it's deleting everything. I had to just give it some time, and it is deleting everything. But that is, yeah, that's it. So again, Kubernetes is a lot bigger than this. There's a lot of things we could have talked about tonight. We could have talked about the thing managing everything behind this, which is etcd. We could have gone over a lot of things like the control plane. Like that includes etcd, but all the different things in the control plane. We could have gone over tons of different things, but Kubernetes is a large thing, and I wanted you to know enough to be able to go through one of these tutorials. There's a bunch of tutorials like this online, and I actually think they have another. Oh, it looks like you can add some more to that. Add logging and metrics to PHP Redis guestbook example. So it allows you to kind of extend that. So actually, if you guys get a chance, go through and try to do it yourselves. If you weren't able to follow along this time, hop in. Try to see if you can go ahead and extend this, but just mess around with it. You don't need to, you don't need to be an expert in 2 days of this. But I want you to mess around with it. I want you to know enough to mess around with it, to at least know, okay, hey, when I get to the deployment section, it's not the same thing as a service. So like, I know I'm doing 2 different things here at the very least. And like, looks like I have an application running, and be able to get the application running and get to it and check it out and see it. And even if you're not 100% sure how it works, that's not a big deal. But the important thing is to know that all the things we were checking here, these are all containers that are running, and we were using kubectl and Kubernetes to manage these containers. We used them to scale. You saw me scale up from 3 to 10 and back down to 2. We were able to easily scale these things very quickly because containers are small. And once you have a single image, you can deploy an unlimited number of containers off of them. So so you can kind of, as long as you already have that image, you can spin up things indefinitely, as long as you want. Yeah. But again, hopefully you got something out of this. Does anyone have any questions? So also we have one. What is config management tool for Kubernetes? Like if you need to update, if you need to do updates, is that what Helm is? Yeah. Partly, yes. So you can use Helm to do things like that. Some people do a lot of those things manually, but yeah, Helm. So Helm is like a package manager for Kubernetes. It's really weird. Let's actually, this is great. Let's pull up Helm. We don't have any, there's no rules here. We can just pull up Helm. But yeah, it's a package manager, similar to how you do things like your apt-get and things like that, and you can use that to do these things as well. Helm is interesting. I actually didn't see I didn't get what it was good for when I first the first time I ever checked one out. I was like, this seems like I don't really need this thing, but I could definitely see how you need it. And bigger things, like I've been doing pretty small things with Kubernetes, but it just helps you help manage your applications and things like that. So Helm is what I would consider to be the configuration management. If you've got to designate something as the configuration management tool for Kubernetes, it would be Helm. So there are a lot of tools around Kubernetes, inside of Kubernetes. There are a lot of pieces. Like Kubernetes is actually kind of a tool that's made up of a bunch of tools. or a bunch of tools and services. So that's where it gets pretty complicated. Again, like that whole control plane is a bunch of different things. And it's like now I got to learn another thing. You don't have to know it super well, but it is important to kind of start to pick up, over time. You don't need to know all at once, but start to pick up, what's controlling this, and like how is Kubernetes actually managing these things, and what's it using to schedule these things, and what's it using to spin things up and pull them down, and like how does it know things are dead and things like that. Are good to know, and that's when you become a real Kubernetes expert. That's when you start wanting to dive in and going to take the certified Kubernetes administrator exam. So there is an exam for Kubernetes if you want to get certified in it. It is, the CKA, CNCF, the people who manage Kubernetes, or who manage Kubernetes now. They're the ones who give it. $300. I've never taken it. I don't know how hard it is, but I think it's a hands-on test. I don't think it's multiple choice or anything. I think you actually have to go through and set stuff up. So we know that Kubernetes pays well, so you can use this to try to prove to companies that a lot about Kubernetes. I know a few people with this. And from what I hear, it's tough, but it's not like crazy hard. But I am interested because when I did that Google search, let's see, Kubernetes administrator jobs. I want to see if this is like, I want to know if people are putting out. Oh yeah, like people are putting out Kubernetes administrators, like jobs for Kubernetes administrators. I wasn't sure that was like a thing. A lot of times it'll be lumped into like DevOps and things like that, but it looks like people are expressing Kubernetes like in the job titles, like, hey, like I want you to be a Linux DevOps engineer, but like you got to know Kubernetes. Like really, this is like really you're gonna be a Kubernetes person, which is pretty interesting. That's kind of all they talk about in here. So like Kubernetes is it's a big deal right now. Like honestly, it's a big deal to really increase your stock. And I don't think it's that, like, there are a lot of pieces to it. I don't think it's good. I don't think it takes long to get good enough to be able to be I guess useful with Kubernetes, and to really go into an organization and start learning and actually helping them out for sure. Horizontal scaling, more clusters. You add more physical hardware to the cluster. Yep. Yes, horizontal scaling. Yes, you add more physical things to it, like pods, like clusters, of the same size. So you don't give it any additional any higher tiered resources. You just you throw more hardware at it. More like replicas of what you already have. And scaling up is taking what you have, but the same amount of hardware, but with more powerful resources, more processing power, more memory, more disk space, things like that. That's what scaling up is. I'm about to spin up my third Kubernetes cluster this year, and I find that I'm still finding new things because there's so many moving pieces. Absolutely. If you really want to know Kubernetes in depth, definitely start trying to learn how to spin up your own cluster from scratch. It's really, I tried it for like half a day, and I was like, this is way more. I thought it was gonna be real chill. I just want to learn, and it was annoying. And I've actually never set up my own Kubernetes cluster yet, just because I haven't needed to. But definitely something I want to dive into. I actually really want to get my CKA, but not because I'm pressed to have it, but like I think trying to study to pass it, I think will give me the amount of information I really want to know about Kubernetes. I really want to know Kubernetes really well. Like I don't know Kubernetes super well. I know it enough I would feel confident going into an organization and really using it to manage their already containerized infrastructure. But like there's a lot of little tips and tricks I don't know about it that you only learn when you're using something like this in production. And like I want to know those little things. I kind of want to get to know those things specifically with Kubernetes. That'd be pretty cool. One I met yesterday sent me a link for a journey for passing the exam. That's cool. Yes, there we go. I was gonna say share it, but you already shared it before I even got to it. So perfect. I'll definitely be checking that out because I am one thing I've learned towards the end of this year, I used to spend a lot of time like spending time in the evenings. Like I would come home and learn something, like watch a video on something, just to like it feels good to learn something new about things you're already doing. Like it's a little more stressful when you're trying to get into the industry. But once you're in, I found it pretty relaxing to like, and pretty rewarding to like, make sure I stay up to date on things, but like learn something new and see like, oh, like this crazy thing that everyone talks about, like it's not so hard, and like, oh, like that's a really cool way to solve a problem and things like that. And I kind of haven't been doing that as much lately just because I've been super busy. But I've taken the time lately because like I said, I'm studying for the AWS Solutions Architect Pro exam, and although I know a lot of that stuff, like diving deeper into the nitty gritty stuff and like learning like the little tiny stuff has been really cool. Like it makes you feel, it's pretty rewarding, at least for me. It's been pretty cool. I'm going to start doing more and more of that. And that's kind of why I want to study for the CKA, especially because Kubernetes is something, again, that I don't know. Like I'm not an expert. I'm definitely not an expert in Kubernetes. I'll tell you the things that I'm an expert in. I know it, like AWS, I feel really good about. Docker itself, I would consider myself an expert in. A lot of other things that we've gone over, again, a lot of AWS. So Linux, I would consider myself an expert in, but not Kubernetes. I'm definitely not a Kubernetes expert. Let's see. An application that's basically 2 Docker containers, web front end, database front end. Does that mean it can run in a Kubernetes environment? It can. Or does it have to be structured in a specific way to work and scale properly? Yes. So your application does need to be set up in a way to scale properly. Especially for things like this, containers period, but Kubernetes, your application needs to be built in a way that's stateless. You can't have a stateful application in a situation like this. Everything needs to be all the state needs to be managed outside of the containers. So if you have that set up right, yes, you can use Kubernetes to scale it. That might be overkill if you just have kind of a simple web application and a database. I probably wouldn't use Kubernetes, to be honest. There are some other techniques. Again, there's less cumbersome things like Docker Swarm or Amazon's ECS to be able to handle that. But yeah, you could absolutely use Kubernetes if you want. If you're willing to pay the money, you can just pass this information off to Google. You can write your manifests, and you can pass some YAML off to one of the managed service providers, and they will take care of all of it for you if you got a little bit of money to spend. Yeah, and applications are developed. Yep, absolutely. What I found is that the setup is very dependent on the environment. Yes, that's also very true. But yeah, is very dependent on the environment for sure. Using with Docker Compose, they're hiring a Kubernetes expert to get the environment worked out so that we can implement it. I mean, yeah, I mean, you can see here, like, yeah, they're hiring a Kubernetes expert to do something that's probably not even all that hard to do, to be 100% honest. And I actually don't think something like that is always necessarily done best by a Kubernetes expert. To me, that sounds like you guys need someone who's familiar with scaling applications and like more familiar with application architecture to find out what works for you all. But yeah, I mean, if you want to use Kubernetes, I don't think you need to be a Kubernetes expert. If it's, especially if it's already set up in Docker Compose, I bet you could figure out how to do it yourself, no problem. And that actually, if you're willing to share any of the information, one of us could probably help you out with that, to be honest. Teaching a lot of different things. I'm sure you're learning a lot of just 1000%. I'm learning so much from teaching this stuff. A lot of little things that I forgot about. I'll learn, like I admittedly I don't do a lot of I don't do much prep besides the slides. I don't do much prep before doing most of the stuff. Again, I've touched a majority of this stuff before, so I'm relying on my experience to kind of be able to get through it. But it makes me a little, like, I actually want to dive into all this stuff a lot more to be really, really good at all of it, to be honest, because there's a lot of different stuff. But I do learn a ton going through it. Like just we'll hit some documents here. I'll be looking for some information to put on the slides. I'm like, oh man, like I completely forgot this does this, and I completely forgot you have to do this. And like I learned so much just from teaching this stuff. So that's another thing. If you're trying to learn this stuff, join a meetup, join a group or somebody. Find someone who's trying to learn this stuff too. Hop in the Slack, and when people ask questions, share what you know. You may not know the answer, but go ahead and try to share what you know. One of the best ways to learn is to reiterate what you know, and to try to teach someone else. That really cements, the things that you do know. It also helps pull out stuff you forgot that you do, to be 100% honest. But absolutely, that's very true. There's nothing wrong with using Docker. The reason Docker is sort of being phased out is more people see the Docker daemon as a single point of failure. That is 100% true. Docker daemon is for sure a single point of failure, but so is any other running application. So that's why I guess that's where you go serverless, but there's still also single point of failure there, because I'm pretty sure all serverless is I'm very confident all serverless is some kind of giant Kubernetes-esque setup that you just pass stuff to. I would be surprised if it wasn't. I actually would be very interested to hop into Amazon or something like that, and to have them show me how their serverless function, their functions as a service things work. It's got to be Kubernetes, or got to be Kubernetes-esque, some kind of a giant container orchestrator, just like Kubernetes. If not, state developed application by a third party. Receiving management in, yeah. I mean, if you can get state out of the containers, like if you can manage them somewhere else within cookies or something, or wherever else in a database, if you can manage state in the database and not in the container itself, perfect. You can absolutely do that, and it wouldn't be a problem. It's not a problem. If you're looking for someone who knows how to do it, I know freelancers who work on Kubernetes, or if anyone here is a Kubernetes pro who can help out Rittenhouse, reach out, because again, there's a lot of money in this stuff. I wonder how much your company is willing to pay for that. I always find it interesting to see how much people are willing to pay for people to do this stuff. I'm going to spec now. You can create containers that don't rely on the Docker daemon. Oh, I didn't know that. The open container spec. I'll check that out. I didn't know that at all. Let me Google that. Yeah, see, all this stuff is so exciting to me. Open. And you guys are going to help me keep up with all the latest tech. Like it's pretty hard to keep up, to know, like to keep up with the latest tech, like to find out what everyone's going to. That's pretty cool. That doesn't rely on a daemon. What is this using? Like LXC? Like what is this? What is this using? I'm gonna check this out. I appreciate that. That's great. I may become I may start like may start trying to contribute to this. I'm gonna be trying to contribute to more open source applications and open source software. That's one of my goals for 2020. Is to like, I really want to start. I want to start writing more code. I really want to start writing more code, especially Go. Like I don't know what it is about Go. I really love Go. And I want to get like really good at it. So this year, I was going to start the end of this year, but I think next year I'm going to spend some time contributing, seeing where I can contribute to different things, and contribute to a lot of this free software that we use every day. Although you see me using my Windows computer here, I'm a pretty big open source software advocate. I think it's really amazing what you can do with open source software, and like what it allows people to do. You could, everything that I'm doing now, I could do. There's an open source software out there that I will be able to do the stuff with. But right now I favor a little bit of reliability. There are some reliability concerns and things like that. But yeah, I think open source software is really cool. I think if you're able to contribute to it, I think you should do that, because the software, most of the time, it helps us all. Because replacing old VM system, financial state, yes, that would be great. VMs, multiple options. Truth is, company A pays company B for a guy to get paid maybe 1/3 of that. Cut the middleman. Yeah, that's true. Always cut the middleman if you can. Always. Container built with spec. Let me check that out. CRI lightweight container runtime for Kubernetes. Oh, cool. I'll try. Oh, that's cool. I'll try this out. I've actually never tried a different driver, a different backend, different container backend for Kubernetes. I would be happy to try one out. Maybe we'll do I'm trying to think of some cool things to do in between when this is over and running the next one. And again, I'm probably going to be running 2 right after the new year, but I'm going to do a lot of different series in between the end of here and the new year. And I'm looking for just interesting things to do. This might spend some time just messing around with some of these container technologies. That is cool. Yeah, so what do we have? I'm not sure what we have left in let's check what we have left in the academy. So we are hands-on containers. We're here, deployment examples of Kubernetes. So we're here. Oh yes, we get to do CI/CD stuff on Monday. CI/CD is probably my CI/CD is, I think, the coolest because I think it makes you feel the coolest, and I think that has to do with the way that things are set up and like the way they show their status bars and the kind of the flow that happens kind of automatically. I think CI/CD, like once you kind of get into CI/CD and like start to understand what you can do with it and kind of get into this tooling, it makes you feel the coolest. Like it's like, oh, look what I did. And some of the newer ways to do that, again, we're going to be using Circle CI for this. And maybe we'll try to dive into, like, we'll be able to get through a pipeline with Circle CI real fast. I'm really interested in GitHub Actions to at least check it out. I haven't tried it yet. But yeah, I might try that out. But CI/CD is really cool. And we're gonna learn how to, like, this is usually a very important piece of the DevOps workflow, and like your job as a DevOps engineer is to really make sure that the developers have these pipelines available to them to be able to deliver code as fast as they would like. And these CI/CD tools allow you to do that automatically. So they'll push some code to GitHub, and you'll basically set up this tool to automate the process of running tests against that code, to building your packages, building your artifacts, and getting those artifacts where they need to go, and getting the code where it needs to go. And deploying these things out to environments. So you can use these tools to do all of that automatically. They're kind of just fancy scripting tools, to be 100% honest. Like, these are all things you could write a script for. But yeah, they're like fancy scripting tools, and they're pretty cool when you see them in action. Monitoring and logging. This will be cool, but like, I think this is gonna be one of the most boring ones. We'll talk a lot about parsing logs and how to get through that stuff, and like how to just set up one. We'll talk about both setting up the different types of monitors and metrics that you can set up, and we'll talk about like aggregated logging and all kinds of that stuff. All this stuff is very important. This observability is very important, but I find it to be a bit boring. But yeah, we'll get through that. And then we'll get to talk some cool stuff. You get to talk to actual people. So there won't only be DevOps engineers. I'll probably change the wording there. There will be some software engineers, people who work with DevOps engineers. But we'll get to talk to some real people. I'm going to try to test it this week. We have these owl cams at work that I was trying to figure out the best way to do this. And like, once someone was like, why don't you use the owl? And I was like, perfect. Like, that's actually perfect. You'll be able to see everyone at once, and when you're ready to ask questions to someone when they're talking, the owl camera is smart enough to point at them. So it's really cool. I think it's the perfect solution for this. Yeah, then we're gonna take 2 hours, and we're gonna talk about how to conquer this DevOps process. We'll do some real tools. I actually have some interesting coding challenges that I've seen in DevOps interviews, and like that I've pulled from that are like publicly available from companies right now, and just kind of talk about if you have to run against those, how to kind of approach those things, but like also just like, how do you sell yourself? How do you talk yourself up? How can you, show a company that, hey, I may not know all the stuff, but this stuff that I do know, I know really well. Like, how do you portray that to someone? And we'll talk about that as well. But that is it for tonight. Thank you for sticking around for our Kubernetes talk. Kubernetes is really cool. Hopefully you see a little bit on how you can use it. Hopefully you can see how a tool like this helps you manage and helps you deploy containers at scale. And one day I'm going to show you how this is done with, we'll hop into EKS or something and we'll do we'll spin up a ridiculous amount of containers, so you can see how amazing it is to just kind of write a little file and kick that off, and Kubernetes do all that stuff for you. But yeah, we'll be back on Monday. That'll start week 11. Yeah, it'll start week 11. Only 2 weeks left. What? Hold on. Actually, how many more? Oh yeah, there are 4. There are 4 left. So 2 weeks left. We'll be done with that right before Halloween. I expect everyone to have a great Halloween. I'm definitely gonna order I've got my Halloween costume. I'm about to order it. I will be wearing it on the last stream, maybe the second to last stream as well. Got to get my money's worth out of it. I hope anyone who celebrates Halloween or does something fun for Halloween, if anyone's going to dress up for work or anything like that, I definitely want to see pictures because I have a good time during that time of year. Just fun, just a little time to. It's fun to be at work and walk around and see people dressed pretty wild. Makes the day go by a little bit easier. But yeah, hope everyone has a great weekend. Enjoy your weekend. Starting to get cold out there, so bundle up, and I will see everyone on Monday. Have a good night.